seconds.
Get started shortly, but just to make sure the first block of the startups out here can everyone from the team that I call out, please raise their hand. So first up we have Valeron. Second, Venture Clap. Anycharge. Albon. And then for block 2 we have Carbon Pad, InsyTech, Training Tech. I'll put the text in the one. And the final one, Liftoff Technologies, Reduce CO2, and Trade-off. Thank you.
All right, everybody can hear me? All right, we'll go ahead and get started then. Here, let's close the doors. Good morning, everybody. For those of you I haven't met, my name is Atib Khan, and I'm one of the directors of this year's Climate and Energy Prize. And I'm so happy to welcome you both to Munich, as well as this very beautiful SAP campus. So just a quick round of applause for all the startups and everybody who made it here today. For anybody who's a little bit less than familiar, the MIT Climate and Energy Prize was started a little over 15 years ago at MIT's Martin Trust Center for Entrepreneurship. And the idea behind the prize at the time was to provide non-dilutive cash grants to early stage climate tech startups, particularly those that were still actively affiliated with a university. When the prize was first started by Bill Aulette and Todd Hines, there weren't really many other competitions like it at the time. We're really excited that now we're part of a family of many startup competitions. And what I've heard from many of the startups here is that this is one of many pitch sessions that they'll be attending over the course of the next few months and years. To remind everybody a little bit of the structure of the prize, the overall prize is gated between 3 different events. This year, we had a little over 160 startups apply from over 30 countries around the world. Now, these startups first pass through an initial screening where they then pitch in a virtual session with over 70 volunteer judges who took some time, and we all met over Zoom sessions over many different time zones. And from those 160 startups, about 20 then proceed to one of 2 semifinal rounds. Oh, Sir, again, let me jump into the camera. One of those semifinal rounds happened last week at the Engine in Cambridge, Massachusetts, where 10 startups pitched and ultimately 5 move on to the final, which will be taking place in about a month over on MIT's campus. Now, the other startup competition is why everybody else is here today. And we'll have 10 startups pitching over the course of today, pitching startup ideas from one of 9 different categories of different areas of climate impact. Now, from those 10 startups, 5 will have the opportunity to meet the other 5 in the Boston final, which will be happening on April 18th. Now, these startups will be judged on a variety of different criteria, which ultimately comes down to weighted 4 separate categories. That is the ultimate solution impact in terms of climate, the solution ingenuity or creativity, but also the team composition. One of the big things that we're really proud of here at the Climate Energy Prize is that we require that at least 50% of every startup has an active student composition, right? So many of the startups here have students who are currently enrolled in universities who will be pitching today. And then finally, the solution feasibility. You know, we're at a time now sort of in our global environment and economy that it's really important for us to begin to think about startup impact as much as it is sort of the pie in the sky and the opportunity in front of us. Now, certainly none of this would have been possible without a village. And I would like to start by first thanking, let's see. First thanking the MIT volunteer team that made this possible. Now, ultimately, the Climate and Energy Prize is an entirely volunteer effort that is led by many of the students you see on the screen here today. And many of those students are actually here present. So I want to first quickly thank all of the MIT students that made this possible. Oops, sorry. Oh, there it is. Sorry. I also want to quickly thank all of our financial and non-financial sponsors. The Climate Energy Prize relies on the largesse and support of corporate sponsors. So I want to quickly thank our megawatt sponsors, Chevron, Equinor, and Amgen, as well as our kilowatt sponsors, AP Ventures, Rose Rock Bridge, Acario, Temasek, Mitsubishi Heavy Industries, Mitsubishi Corporation, Mintz, as well as the MIT Sloan Sustainability Initiative and the MIT Energy Initiative. Finally, I wish to thank all of our non-revenue sponsors, which first specifically want to call out both Greentown Labs and The Engine, who are our host sponsors over back in Boston. The Engine is a venture and investment firm that hosted our semifinal last week. And Greentown Labs is also an incubator based in Boston that helps support climate tech startups and will be hosting one of our receptions for the final. And certainly, last but not least, I want to thank both TUM and SAP for hosting us in this gorgeous space and for providing all logistic support to make this event possible. So now I want to quickly hand it over to my colleague Lars over at TUM to say a few words.
Thank you, Artep. Thank you, Alejandro, and thank you everyone from the MIT team. I'm really, really happy that we could make this happen. My name is Lars Eiermann. I'm running at the TUM Venture Lab the sustainability activities, and also a lot of thanks to my team supporting this great event today, especially you, Anna, but also all the others behind this. So big thanks. I'm really, really happy that we could make this happen. When I first talked to Todd roughly a year ago, and we said, let's do the climate venture course at TUM as a cooperation with the climate energy ventures at MIT. That was already a fantastic idea, and in the meantime we realized let's do more. Let's connect those ecosystems, let's bring it together. And then we said, okay, why not hosting the semi-finals here? And we were excited right from the beginning, and thanks to the great support of you and your team, it was really an easy run for us, to be honest. There were much more hard preparation for other events, but I'm really happy to have you. And it's, for me, the main thing is connecting the bridges, bringing people together, especially in those critical times we have today, or transatlantic, worldwide. I'm really, really happy that we have with the MIT such a strong partner who is also interested to work with us and vice versa, so that it could be a win-win for both sides. One example, like today, I'm really, really happy that Libby is joining us. She already supported us a lot for the climate energy course from Breakthrough Energy Ventures, but also related to the MIT courses. And that we have the people from SAP, like with Tobias. And a big thank I also have to say to Stefan Wagner, who cannot be with us today due to a hospital thing, but nothing curious, and all the other SAP colleagues, and that we can be in this fantastic place, because I think if companies bring their research on the ground, together with universities, I think it's a perfect opportunity to push innovation, to bring things forward. But for sure, the main idea is scientists to startups. That's the reason why we're here. That's the reason why you're here today. I'm really, really happy to push it. For sure, I'm proud that out of the 10 teams, 3 teams are from TUM, which we're also pushing. I will be independent as a judge, and I was not involved in the pre-selection. So everyone has to convince me, and all the others. And I'm happy, for example, that also with the other judges from the MIT side, but also Claudia from our campus in Straubing, looking on this from the research perspective, and Tobias from the corporate perspective. So I think it will be a fantastic day. And now I want to hand over to Johannes. Johannes is a good colleague from the SAP side, and on the lab side, strongly working and with a passion for sure for the innovation topics. And thereafter, I'm happy then also to have Tobias, I would say, as a 100% TUM person on SAP side to drive this spirit forward. So Johannes, the word is yours.
Thank you. So also from me, a very warm welcome here on our campus today. So as mentioned before, this is a very special place for SAP and also for the TUM, as we are indeed on campus ground here of the Technical University of Munich, one of the few distinct partners we're allowed to build here. And this building actually signals also the quite intensive and unique partnership we have here with the TUM, where Tobias will touch upon later. But yeah, what are we doing here? And so we are part of the SAP Labs network, which is the global R&D network of SAP, with 21 labs across a lot of countries worldwide. And here in Munich, we are part of the German engineering hub. We are the third largest location next to the SAP headquarters located in Walldorf and to Berlin. So we have here indeed more than 1,200 employees working for SAP. I think more than 600 of them in R&D functions, quite a lot of students as well that come on top. And we have roughly around 400 or 500 people working on customer-facing roles, services, deliveries, sales, and I think more than 100 in corporate functions like marketing, HR, finance. And yeah, I think the unique thing is that we are here sharing also this building, this location together with the TUM. So there are more than 120 employees of TUM, professors, students, and employees of TUM working us together. We share meeting rooms together. We share our canteen together. And we also do research together that culminates hopefully in product innovation. But yeah, what are we doing here exactly? What are we working on? So we are quite a diverse location, taking almost over, I think, a good size, a good breadth of the SAP product portfolio. The main important parts are Cloud ERP, public and private here, which takes the biggest part of our R&D employees here. Of course, our new growth area, supply chain management, where we focus on a new state-of-the-art cloud-native logistics management solution, and customer experience, where we focus on SAP Commerce and bring that to transition that to a modern cloud architecture, improving container orchestration, scalability, performance. And of course, also very important, the technology stack from SAP, the business technology platform, where we focus on two parts here, innovation and the foundational planes, which enables all the services that run on the BTP for our customers. Yeah. We have several other smaller areas like SAP Signavio, process management and sustainabilities, and also some industry teams, as well as mobile engineering teams here in our location. And how that all comes together and how we actually then transfer also the research topics into our products, that is something that Tobias will now touch upon.
Thank you, Hannes. Give me a chance. Please come on stage, Tobias. Two things before I jump to former TUM student in all ways, and then jumping to SAP for sure. The most important guests are you as scientists and students here, and we're looking really for the future. And if you go deeper in research, I'm really happy, Johannes, you mentioned it, what you're all doing here. For sure, also Gerhard Kramer is a really interesting person here to have with us in the room. He's our SVP for research. So whatever is related on the TUM side to research, Gerhard will be the person to talk to. And now I'm happy to give over to you to show a bit from the TUM perspective and the SAP perspective. Thanks, Tobias.
Yeah, so thank you for having me. My name is Tobias Möhr. I'm part of the SAP Munich team as well, and I'm responsible for the collaboration between Technical University of Munich and SAP. And I want to give you some more insights on why we collaborate, and especially on how we collaborate, on how we do research-driven product innovation, and also what makes us unique. So as you already know, we have this beautiful building on the TUM campus, but of course we also want to create impact together. And this is more than just having a building and having this close proximity. And this is why we established this larger collaboration between both parties, between the largest technical university in Munich and between one of the largest tech giants here in Germany. And so if we talk about industry university collaborations and also in information systems, we always talk about the rigor and the relevance and on how we want to build these bridges and how we want to create impact together. And the thought is, talking about rigor and relevance, we from the SAP side, we can provide the relevance, and from the TUM side, we can provide the rigor. So even though we have somehow different perspectives and different goals in mind, so university want to publish papers, they want to do research, they want to explore new things, and we as SAP, of course, we want to drive our products forward, and we want to sell them. So there are some different like primary goals we have, but by collaborating, we can have this mutually beneficial collaboration as well. And to set it up, we thought that we will structure this collaboration into 4 pillars. So on the very largest space, we have the applied research and development, which means that we have one applied research projects, which then fosters like publication, fosters research, but also fosters this research-driven product innovation. Right now, we have a portfolio of about 15 applied research projects. 8 of them are on AI, on like auto evaluation of retrieval augmented generation pipelines, on how to create synthetic data to train foundation models, and also for how can we use the new like NLP techniques to do process mining, basically. And all these research projects then foster knowledge exchange between like from TUM experts, which speak at SAP, and also SAP executives who will speak at TUM. Then we have some research ecosystem and collaborations, and also, of course, some talent attractions. And as you know, it's hard to do this technology transfer from research into actual products. So this is also why we set up this very unique collaboration. And so I want to go into a bit detail what like makes us different, what is our unique approach here. And if I would boil it down, this would be 3 things. So we established a unique governance model between TUM and SAP. So there's a strategic advisory board, there's a collaboration board. We have one party on the SAP side who builds the bridges into the SAP world, and we have one party on the TUM side who builds the bridges into the TUM world. And these 2 parties, they closely collaborate. On the other hand, we have predefined legal framework on an institution level, which means we have IP protection, and we can give the researchers user access into our systems from day one. And on the 3rd level, we have this unique industry university collaboration hub. So what we do when we establish a project, we have one product team, and we have one dedicated technical lead who is responsible for the project on the SAP side. Then, of course, we have the researchers on the TUM side. And in between, what is unique here is that we have this industry university collaboration hub who is responsible for change management, who is responsible for the ongoing project support, to define legal frameworks, and so on and so forth. And also, this enabled us to have around 30 plus publications for high-ranking academic conferences, but also on the same projects to have new product features and new product capabilities, which we already tested with our customers. Of course, there's not a lot of time, so if you have any questions about it, feel free to write a message, hit me up, and then to connect. And yeah, thank you. Welcome to Munich. Enjoy the local culture.
Thank you so much, Tobias. Thank you, Lars and Tobias and everybody else from the TUM and SAP teams. Very excited once again to kind of learn from the legacy of collaboration. And hopefully this is something that we can continue to learn and many of the startups can learn from. Now, as we jump into the meat of the competition, I just want to remind everybody of the schedule or the run of show for the rest of today. So we are just concluding our welcoming remarks, and we'll transition directly into our first 4 startup pitches. As a reminder for everybody, each startup will have approximately 7 minutes to deliver their pitch, followed by 7 minutes of Q&A. In some cases, some startups have hybrid teams, so they will have Q&A and responses that will be coming virtually via our Zoom platform. followed by a quick coffee break. We are in Europe after all. We will then have our first of 2 different panels. We're excited to have different panels and speakers, and we'll get a little bit more in depth about what those will be in a short amount of time, followed again by 3 startup pitches, and then by lunch. After that, we will have our second of, or excuse me, there will be our second of 2 panels, followed by our final pitch block of 3 startups. At that point, our judges, who will be responsible, and we'll get to this in just a moment, for submitting their feedback will break out, where we will have a separate judge deliberation session. Upon the conclusion of that deliberation session, we will then be presenting the winners of today's competition. As a reminder, there are sort of 2 categories of winners. First is the top 5 startups out of our 10 that we'll be pitching today. We'll have the opportunity to move on to the Boston final on April 18th. But we also will be awarding the top prize for today's semifinal, which will be a $5,000 cash grant to the #1 startup from today's competition. So exciting things. And before we jump in, I want to quickly introduce our judges. First, we have Ellen Smeal, who's an investment manager from CEP Ventures. So thank you, Ellen, for being here. We have Shanaz Khan, who is a senior associate at 2150. Everyone here has already heard from Lars, who is the Chief Sustainability Officer at TUM Venture Labs. We have TUM Professor Claudia Doblinger, who is an Associate Professor here at TUM. We have Pavlos Kalecjoglu, if I hope I pronounced that correctly, who is a Scientist in Residence at Astanor. And then finally, we just heard from Tobias Gefeier, I hope I pronounced that correctly, Tobias, who is the CEO and Head of Strategy at SAP Sustainability. So these judges will be responsible for asking questions of the startups and ultimately will be the deciders in who gets to move on. So without further ado, we'd like to quickly introduce our first startup, which so quick applause for Babylon.
All right. Hi, everyone. We are Valeron, and we turn waste into value. But why does that matter? So when you look at the world in 2050, there are a couple of gigaton scale problems that we need to solve. On the one hand side, we have the waste problem. So even today, we are already producing roughly 2 billion tons of waste per year that is mostly ending up in landfills, so leading to huge methane emissions. And that problem is going to nearly double by the year 2050. And then on the other side, you have industries like the aviation sector, like the maritime sector, that will still require large amounts of fuels in the future. And you have sectors like the chemical and materials industry that will still require carbon-based feedstock. So our goal is to solve these problems at once by turning waste into chemicals and fuels, and therefore tackling a global emissions baseline in 2021 numbers of 5 gigatons. That's roughly 10% of global emissions. But how do we get there? We have developed a process at TU Munich over the last 5 years that consists of mainly 2 steps to make this happen. The first step is what we call a thermal decomposition process. There we take in mixed waste, can be any kind of heterogeneous waste that is containing carbon-based materials. And all that we need is that you can shred it down to roughly the size of my hand, so 300 millimeters in diameter. We then convert this into intermediary products, that is a gas phase, an oil phase, and a char phase, so a solid phase. And these products are being upgraded before they are being sent into the second phase or a second step of the process, that is the e-conversion process. This is a very high temperature process, 1400 degrees Celsius on average, where we use a high temperature steam plasma to decompose those intermediary products into hydrogen and carbon monoxide. And we can then use this, what we call a syngas, to produce chemicals and fuels via standardized commercially available processes. So for example, methanol synthesis. What is great about the process is, as I said, we can take in mixed waste, so waste that currently cannot be recycled. We also convert it at very high efficiencies. So when you look at 100% carbon that is in the feedstock, we turn 95% of that into the end product. And we're doing this at high energy efficiencies. So roughly, when you look at the e-conversion process, for example, we have 80% efficiency in there. What is also great is that the intermediary products we produce with our decomposition process, because of the upgrading we do, they are already marketable. That makes it possible for us to scale this in 2 steps. In phase 1, focusing on the decomposition technology, and then in phase 2, adding on the e-conversion process. But let's dive a little bit deeper into the unit economics of this. So when we look at 1 ton of waste that we use as reference here, we produce roughly 50% as gas, 25% oil, and 25% char with our decomposition process. We then have the option to sell the oil and the char on the market, or in phase 2, to send it into our e-conversion process to convert it, for example, to methanol. They are depending, of course, on the exact waste we feed in. We have different yields, but roughly 80% ends up as methanol. So let's have a look at how we can generate revenue here. When we look at the waste input that we use, as I said, we can take in waste that currently can only be landfilled or incinerated, so there is a gate fee associated to that. In Europe, roughly 150 euros per ton. In the US, it's a little bit less, but combined, this waste fee combined with the char sales we have, for example, into the cement industry, there we are talking with Rohrdorfer Cement, who are a large-scale cement producer in Germany and want to replace some of their mineral feedstock with our pyrolysis char that we produce here to produce a carbon negative cement, and coupling this with additional revenues from the oil sales, selling into refineries, into steam cracker units, and into HEFA plants, and the maritime sector directly. There we are in talks with Hapag-Lloyd, one of the largest marine shipping companies, for example. This all makes it possible to generate significant profit, around 200, 240 euros per ton, that we can realize with phase 1 of this whole process chain. Then in phase 2, the goal is to capture even more value. So we are sending the oil and char not to the market, but into our e-conversion process and converting it to methanol to then realize a profit of roughly 450 euros per ton. All this, of course, sounds quite interesting, and therefore we want to scale this aggressively. So when we are looking at our 9-year vision, the goal is to have an installed capacity of roughly 1 million tons of waste that we can process. That means we have to build 11 decomposition units, and then our first-of-a-kind e-conversion plant that is also connected to 10 more decomposition plants that feed into this e-conversion process. That makes it possible for us to generate significant cash EBITDA that we can then use to, of course, scale faster and accelerate everything. But we need large-scale equity investment for that, of course. And here our goal is to go for a numbering up approach. We are currently in phase 0 of this, so we are building a pilot plant already that is funded by the German government with 2 million euros. This will go into commissioning by the end of the year to then have first customer runs in 2026 with real waste, turning it into feedstock for our end customers so that we can secure offtake agreements. And that's what we want to use the prize money of the MIT Climate and Energy Prize for. The goal is then with these offtake agreements to really go into scaling, build our first-of-a-kind decomposition plant, and roll this out as a factory, as a product approach. And using the cash EBITDA we generate to decrease the amount of equity we need to take step by step. That brings us into a position where by year 6, we can add 5 new decomposition plants per year, and we can start building our first e-conversion process. So that after 9 years, we are able to really accelerate the scaling here and add 12 new e-conversions in the 5 years thereafter, so by year 14. These numbers sound very interesting, and we think they are very solid. So our assumptions are rather conservative, and they are based on more than 50 expert and customer interviews we did over the last months. And in addition to that, we believe that we are also in a really good position when looking at the competitive positioning. So as I said before, we can take in wastes no other thermochemical recycling technology can take at the moment, and we have very high conversion rates. I was talking about the 95% carbon conversion efficiency, but we also generate roughly 70% higher yields than the competition. So very well positioned on the competitive side, and we also have a great team. We have business experience from my time at McKinsey. We also have Vincent's experience from his time at Form Energy, so early stage startups. And we have Marcel, who's really good on the experimental work and the technical side. So combining all this, I think we can really make this happen. So let's do this together. Let's tackle $1 trillion of market opportunity by 2050. And more importantly, let's get rid of those 4 gigatons and more of CO2 emissions. Thank you. Questions?
How does it work that you can have
huge conversion, or sorry again, why do you have so high conversion rates? How do you do it? What is the magic, the technique behind that this works? Because I mean, competition is already out there and very well. Why are you so much better than the competition?
Right. So what we basically do is we leverage the thermal decomposition and also the e-conversion. We leverage that thermal, use of the material with renewable electricity, right? So in the thermal decomposition, we do electric heating. Electric heating, I mean, theoretically has 100% efficiency, right? So in the total you have 90%, and you lose another 10 to heat losses. In the e-conversion, we use plasma technology, and it's the same thing, right? We convert electricity into a steam plasma at 90% efficiency, and then you have another losses in the system. So that is the standalone units, right? Of course, if you look at the overall process, you lose another percentage in each and every step. So you end up roughly around 75%, 70% in energy efficiency, right? Just talking about, the energy yields.
And maybe to add to that, so what makes our process special on the e-conversion side, for example, when you look at other technologies, they focus on oxygen or air that they use to produce their syngas. We focus on steam. So with every oxygen atom that we bring into our system to convert the carbon to CO, we also get an additional molecule of hydrogen kind of for free. And that's how we can boost the hydrogen to CO ratio in the syngas that we have after the e-conversion process. And we also have, with the high temperature electrolysis technology we are developing at the chair, we also have an additional hydrogen boost to the syngas. So this combined makes it possible to have very low losses in terms of CO2.
Yeah, so we're currently in the discussion. We just signed or are doing the NDA with Hapag-Lloyd, and I think they're very interested in that. Regarding the cement industry, these are actually one big partner we have in the project with the 2 million. So we talked to them. So yeah, this is the current status.
And maybe regarding timeline, so the goal is, as I said, the pilot plant will go into commissioning in Q4. Then we will run on like real waste next year. And I think this will be the critical step where we then can show, okay, with this waste feedstock, we achieve this end product specification that exactly hits what you need. And therefore we can sign the offtake agreement. That is the current plan.
Yeah, thanks. I'm really not an expert in this field, so I'm gonna just use logic in order to make that question, which might not be the right thing to do. But if I look at your process, you find waste that cannot be recycled, then you take it, then you're processing it into, by using a specific method, into oil, right? And you are generating carbon footprint during that process. So my question is, have you conducted a full LCA to measure how much carbon footprint are you producing throughout your pyrolysis and all the rest of the processes you're using?
We didn't conduct a full LCA in that sense regarding to standard. Just to give you the overall system boundary again, right? If you put in waste, and technically it comes from a fossil source today, right? So let's say plastics, it's in there, it came from crude oil. So it really depends on your end of use case, right? If we do oils, we intend to also go into chemical industry. So that would mean that carbon would be, again, be bound in a form where it's not released, right? So the only emissions we have is scope 2, like process emissions, and they basically come down to electricity, right? So we will use a lot of electricity, and depending on the carbon footprint of that, you will get the carbon footprint of your product. You also have a biogenic part in your waste, 50% roughly. So that is always green, right? So if I, by balancing, put this green carbon into, let's say, the cement industry, this is carbon negative, right? And then you always add the process emissions.
Is there, I know that you have good intentions, but is there a risk that your carbon footprint is eventually higher than the one generated by the traditional processes?
Let's say there's the risk if we use today's grid electricity in Germany. Yes.
Okay, thank you.
Now our calculations say we are roughly around the fossil emissions with that grid electricity, and it will drop. So you will have reductions, but of course,
Let's see. Let's see.
technically, if I use electricity from coal, for sure, yeah. And it really depends on the location of your plant, and of course, you would choose your location regarding to electricity price. Low electricity price normally comes with high renewables in the grid.
And maybe to add to that, so when we started developing this process, the goal was really to go for waste feedstocks that don't need much pre-processing. So we don't need any sorting and so on, because we want to scale this also to countries that especially today are doing landfilling. And therefore, if you compare our process, where at the, let's say, worst case, you sell everything as fuel in the end, you are producing CO2 emissions, right? But you're competing with a process that is currently leading to large-scale methane emissions. And that's where you already have a huge improvement on the status quo. So even on that end, like if we scale this, and especially into those countries like Brazil, for example, with whom we have a cooperation, where they have a lot of landfilling, I think that's where we can have a huge impact. But also, we did a simplified LCA, so not taking into consideration, for example, all our components and what their footprint is and so on, but rather what our process has. There we have significant reductions, and especially if we secure PPAs for green electricity, then they lead to these 4 gigatons of CO2 that we can save that I have shown.
Thanks.
One quick question. 30 seconds.
Hi, how much exposure do you have to commodity pricings?
That of course depends on like what we sell into. We have some customers like Hapag-Lloyd, they are more interested in having a fixed price that they pay. There are others that are not in that mindset yet. They rather want to have some kind of linkage to commodity prices. But of course, for our cost baseline, we do have some link with regards to the electricity price we have to pay to commodities. But when you look at our waste feedstock, for example, there is no linkage. So especially at the beginning, like the first plants that we are going to build, we will probably convert some of the gas that we produce in the decomposition to heat the process. So not go for electricity there, because that only makes sense if you're below 7 to 8 cents per kilowatt hour, then electric heating is economically feasible. So there we have even less exposure for those first plants, so to say. And that can be, of course, a benefit because the end customers don't need to hedge themselves. But yeah, that will be an interesting negotiation. Like, where do you allocate this value that you are less bound by the commodity prices?
Okay, so it's
Thank you again to the Valoron team. Next up is Ventrix Labs. Yes, just one second. I cannot find the mouse. Ventrix Labs, everybody.
Thank you so much. Hi, everyone. We're Ventrix Labs, and we're here because we're transforming buildings around the world into carbon capture hubs. So buildings are responsible for, well, they contribute to 26% of the global energy-related carbon emissions. 1/3 of this is direct emissions, and that comes from things like on-site fossil fuel burnings from like gas boilers. So we work quite closely with the NHS, which is the National Health Service, and they manage most of the hospitals in the UK. And they've explained to us that they can't switch out their gas boilers to electric because of energy grid constraints and also a major cost barrier. Turns out over 74% of buildings in the UK are facing the same issue, and they're still having their needs met by natural gas, which are these direct emissions. So buildings are one of the hardest sectors to decarbonize, and we want to ask, how are we going to reduce the emissions gap in buildings? We're ultra low energy, bolt-on, decentralized carbon capture. So we integrate seamlessly into buildings, into ventilation systems, where you don't have to replace any of your boilers, but we still directly solve that emissions gap. This is our technology. We harvest excess energy within the building, excess heat, and idle airflow to capture extremely low energy. So the air flows through, we absorb the carbon, and then we release it to either be recycled for breweries and hospitals for use, or we remove it for our commercial buildings or our high energy usage buildings like data centers. We permanently inject it underground. So we're incredibly space efficient. We are up to one cubic meter, and we are 90% more energy efficient than traditional direct air capture. And we capture around 30 tons of carbon per year. Our patent is filing and due to close at the end of the month. So we've realized we're not only solving a climate problem, but we're also solving a cost problem. So if you take breweries, for example, they emit twice the amount of carbon that they take in. And this also is incredibly inefficient, both sustainable-wise, but also large breweries face extremely volatile pricing, and small breweries face premium retail pricing. So it's very expensive because they can't capture carbon in bulk. And we're addressing both of these. They're part of our vertical one, which includes food and beverage industries, but also hospitals. So what we've done is we've identified an immediately profitable market where we've been able to match carbon as a product in price, but also and often actually be a cheaper alternative. So this is about 1/3 of our target market. And we're going to be we're going to be targeting 2,200 breweries in the UK, which is about 4% of our available market. This is our vertical 2. Which is in the built environment systems, where we are going to be bolting onto ventilation units around the world that are suitable for HVAC carbon capture. And this means we're going to be able to capture about 2.16 gigatons annually. We're going to be starting with strong regulatory and buildings with strong regulatory and financial incentives like data centers. And over the next 7 to 10 years, bolting onto about 25,000 sites. Our go-to market. So this year, we're going to be doing our vertical 1 rollout. We've established 3 to 5 trial partnerships with breweries. And then over the next few years, we're going to be continuing direct sales, so bolting on to over 60 units in breweries, and then doing our vertical 2 rollout with data centers. In 5 years, we're looking to continue these, but also then license to estate developers. So this means that they can involve our units in their construction and their design, and then by the time that's complete, they'll be fully operational. We operate a subscription model. So we do a rental and servicing fee where you have access to the units, the software, and the maintenance. But then we also charge per ton of carbon. And this is a weight-based pricing. So it's similar to when you purchase carbon as an offsetting credit or as a product. Our unit economics. So for our V1, our current payback period is 2.3 years, and our projected period is 6 months. So our V2, we're looking about 4.4 years. And again, we're up to 90% more energy efficient than traditional direct air capture. On top of this, we can provide stable and low cost carbon in volatile and merchant carbon markets. We are modular and easy to bolt on. So in the 3 days that it takes for us to bolt onto your building, you do not have to stop any operations. Everything continues as normal. And we are attacking over 5% of global direct carbon emissions. In our vertical 1, we are on par with energy efficiency, but we are really winning when it comes to space productivity. And with our vertical 2, we're winning in both efficiency and space productivity. In just 6 months, we have reached technology readiness level 5. So our technology works. We have validated it in the controlled environment, and we are partnered with Cambridge University Data Center and their David Attenborough building, which is a commercial building. So we have, and with them, we've done virtual simulations, which has not only proved our feasibility, but also our business case. We've had over 120 conversations with buildings across the UK and the US. We've done 7 site visits, and as of this morning, I think that's 5 letters of intent signed. We've confirmed our business cases. We've done our operational pipeline with these partners, and we have got 2 material suppliers and have established our testing partnerships. We're in Q1 in 2025. Our patent is again closing at the end of the month, and we have our trials planned for this summer. In 2027, we're going to be capturing 12,000 tons of carbon per year. We are a full student-led team. We are a fully technical team as well. Our CTO has over 7 years of manufacturing industrial experience. Our CEO has led startups before. The CEO and the COO have software engineering backgrounds, and we have researchers in mechanical design and electrical engineering. We've got incredible advisors. Professor Ronnie Pini is a leader in carbon capture at Imperial College. We are also an Imperial College-based team. And we have amazing advisors when it comes to experience in commercializing climate tech and deep tech. And our partners have been involved with us every step of the way, both in terms of iterating the product and in terms of regulatory alignment to make sure that we deliver something that the world wants. So thank you so much. Please join us for this net zero future. We're net zero built in. And this is how we'd allocate the capital. It'd be going straight towards our trial and also for our business development. So thank you so much.
Presentation. I had a question on the value proposition for data centers and commercial buildings. I think your value proposition for breweries is really clear, but could you speak to the economics and the drivers for commercial building owners in a little more detail, please?
Yeah, absolutely. So actually, if I could have some help, our CEO and CTO are online and they'd like to be involved answering. Can you show me how to? Oh, okay, great. Thank you so much. So Sunny.
Yes, hi everyone.
We can hear you.
Sorry. Hi. So for the commercial buildings, they are incentivized to act on their direct emissions as of today. So previously, for example, a lot of the industrial plants, if you want to kind of reduce the direct emissions, you're putting on these carbon capture units onto your plants, and that significantly disrupts your business operation. And what we're doing is we're bolting onto the non-process buildings, so you can start reduce your direct emissions right away. And another great thing is that compared to nature-based solution alternatives, that we are much more verifiable and it's on site. So it will be not a volunteer credit. This will be a credit within. This will be insetting credit directly in your building, so it can be directly reflected on your ESG reports as well.
Amazing, and I know it works. I have personal knowledge of this one. I've used one of these devices in the past when I was still working for indoor vertical farming. And later on, when I joined the VC, I talked to several of the companies in the space doing direct air capturing. There is one small issue with this one, not technical one. And I know that you're already in the third generation of technology, and you're doing it in a much more efficient way than it was done 10 years ago. But the companies I've talked to, they promise that they will capture and deliver carbon dioxide to the greenhouses, because it's very important that you increase the carbon dioxide levels inside the greenhouse, because that's what the plants are using in order to grow. When I talked to the growers, they told me, why should I use this technology when it's costing me 300 euros per ton and I can buy it for 75 euros per ton? So that's the only issue, the only remaining issue, or that otherwise everything is excellent. So my question is, how are you going to tackle this big problem?
Yeah, thank you for your question a lot. So I want to differentiate ourselves from the technology you just mentioned, which is Skytree. And I think our use case is vastly different. In greenhouse, what we're trying to do is carbon enrichment. We're trying to do from 400 ppm to 2000 ppm so that we can feed the plant with the CO2 they need. In Ventrix, in our V1, what we're doing is we're facing breweries, which in carbonation, we need liquid CO2, which is very pure, to put in drinks. And we can see the product stream of these two technologies are different. And let's go back to the point of price. And especially in UK, liquid carbon price is very volatile. It can range from over 300 to 3,000 pounds because there are plant closures in the UK. And from our conversation with breweries, they're really struggling with the cost as well. So on the fiscal side, they're really motivated to get alternative carbon sources so that they can remain the price stability for the operation, if that answers the question.
So your market is just the breweries?
This is our V1, which is immediately profitable, and we can see there's a great margin in that.
Thank you.
First of all, thank you for your great pitch. Just a question, I don't know, as far as you can talk about it, a bit more on the patents and the IP you're going for. So what do you have specifically in mind, what you can protect? What is the sweet spot?
So right now we've basically drafted our first patent. It's finalized and we're just waiting to file depending on our strategy. We're patenting our mechanical integration of the chemical engineering. That's where our first patent is going to lie. And then we're going to create something called a patent thicket, which I'm sure everyone's heard of, which you kind of just create the spiky fence and defend ourselves. So we add more and more patents to kind of extend that fence as far back as we can. So we're working on IP strategy with our patent attorneys, and we're going to hope to license our tech in 5 years. So we're going to keep building that family as much as possible. If that answers your question.
I was more. Maybe you can go back to your tech demonstration, where you really see the sweet spot. I think it was the other one. I don't know which. Where you really the one before, where you really have the sweet spot where you would say, okay, there we differentiate from other solutions on the market.
Yes. So our mechanical design means that we're really, really energy efficient compared to DAC, which is where we differentiate in the patent space. So our mechanical design and leveraging the excess heat and the excess airflow is really where we can kind of file and win when it comes to us, if that makes a bit more sense. That's obviously we can't disclose all of that, but that's mainly our integration is our main value prop on the IP side.
Yeah, maybe one on the DC on the data center use case. I mean, as SAP, we also operate several data centers around the world, and we're working with some of the competitors, also like Climeworks, to also compensate via direct air capture. So at a scalable level, at the level of a data center, why would we work with you versus the economics of very large scale DAC? Like, is there really an edge, and at what point in time do the economics work for large scale DCs?
Yeah, I can take that question. Yeah, so we are currently working with University of Cambridge data center, and they've told us their current other alternatives are around 1,000 pounds per ton of CO2 removed. So this includes any sort of clean technology. And our pricing within Vertical 2, which is data centers and commercial buildings, are already below this point. So this is why we're able to move forward with the business case. And at scale, they're incentivized to work with us because we are actually within the building. So this is a direct emission. So we are not a volunteer carbon reduction credit. This will be directly reflected on your ESG report. So from a due diligence point of view, this is much more easier as well. If that answers his question.
Maybe a quick follow-up. How do you envision to operate this? I mean, you have like 60 or more units. So is this something that you also want to own from a value chain perspective, or are you working with partners, basically building the machine and then giving the operations to somebody else?
Yes, so for our vertical one, we kind of already defined that the business model is going to be subscription, but we recently actually just found out they're actually very, very willing to pay for the manufacturing model. For vertical 2, working with data centers, we are going to kind of trying to split the capex between us and the data centers themselves within the business model, so that we can effectively scale, but at the same time to split the burden of the capex, so we don't require significant investment for us to roll out within this market. But because we are also already rolling out a lot and saturating the vertical 1 market, we have substantial cash flow, so we can support our exploration within vertical 2 as well.
Thank you. Thank you again to the Ventrix Lab team. Next up is AnyCharge. Do you have anything on that?
I know we don't find this. Thank you.
Welcome to the pitch of AnyCharge, where we are democratizing the access to e-mobility. The issue we're seeing today is that there's a lack of around 50,000 chargers in Germany alone. This means that EV owners struggle to find vacant chargers, for example, their employer. On the other hand, employers cannot build more chargers due to a limited energy supply on site. To summarize the issue, not every parking spot can have a charger. Our solution? A plug at every parking spot, but not a charger. The main component of our hardware is our central control unit, which consolidates the hardware that would be usually installed into several conventional and individual chargers. Our central control unit is connected via cables to Type 2 charging plugs, which are installed at every parking spot ready to be plugged into an EV. But how do we solve the issue of the limited energy supply? We do that with our smart charging schedule. It is based on the available energy supply, dynamic energy prices, local solar energy, as well as parking times. Our smart charging schedule allocates which EV is charged when and at which power level. At any charge, we create value by democratizing the access to e-mobility. We are maximizing the use of available energy supply. We are providing 6 times more charging plugs than conventional solutions. And we are leveraging time of use pricing in order to minimize the cost. Looking at the current solutions on the market, AnyCharge is the only provider that offers both lean hardware as well as a smart charging schedule, making this our main USP in order to minimize costs as well as CO2 emissions. Speaking of CO2 emissions, let's have a look at our climate impact. We create CO2 savings through EV adoption as well as renewable energies. We create CO2 savings from EV adoptions by providing 6 times more charging plugs and thus boosting the attractiveness of EVs with 0 direct CO2 emissions. Additionally, we create CO2 savings from renewable energy by maximizing the local solar energy use as well as optimizing the consumption when renewable energy is abundant. Let's quantify this. Our CO2 savings from EV adoption are nearly 34 million tons of CO2 per year. Additionally, our CO2 savings from renewable energy are nearly 90 million tons of CO2 per year. And now, onto our business model.
Our business model is based on a mixed revenue model, offering a comprehensive hardware as well as software solution, which really is there just to scale and be flexible for our customers. Our B2B customers make a one-time purchase of the central control unit. Same applies for the charging plugs and the onboarding fees, which are charged at a unit rate. Lastly, we also have our smart charging schedule optimization algorithm, which is basically charged on a SaaS service basis. This entire approach makes sure that we have a mixed balance between upfront revenue and recurring income. Launching in Germany alone presents significant revenue potential. Nearly 500 million euros from our hardware sales and onboarding fees alone as the upfront revenue. Additionally, we estimate nearly 60 million euros annually in recurring income from our SaaS sales. With a growing demand of EV charging infrastructure worldwide, we see a very strong potential for our scalable model, really positioning us with a strong penetration in the market and global future expansion. Global expansion unlocks us the access to an international market growing at a rate of annually 31%. We have a list of proven successes to date, including winning the Samsung Accelerator program called Solve for Tomorrow, presenting at key industry events such as the IFA and the Solar and Storage, as well as building a strong network within the TUM ecosystem. Furthermore, we've really engaged with different customers, potential customers, and also industry experts to validate our key performance metrics. On top of that, we're backed by the Exist Founders Grant of Germany. The Founders Grant has already been officially confirmed and is starting as of April 1st. The next step will be the legal company formation in order to really establish our legal framework for our MVP projects. The in-house MVP testing will then be followed by our final contract signing with our MVP customers, where negotiations are already underway. The MIT CEP prize money will be used and really strategically allocated to the MVP hardware, the CE certification, the customer-facing interface, as well as the marketing and sales actions. Shortly after, we aim to make MVP installations at our pilot locations to really drive the real-world validation. Now let me introduce to you the team behind AnyCharge. Our core team consists of Valentina, Ashwin, and myself, Sophia, all having different backgrounds and bringing different expertise to the table. Valentina is our expert for the car and charging station interface. Ashwin is our expert on the hardware controller design, and I'm the expert for the optimization algorithm. In addition, we're advised by a number of industry experts, whose insights and also support we deeply value. Now, join us in powering the future with a plug at every parking station. We're ready to democratize access to e-mobility. Are you in?
Hi, thank you for your presentation. And I like the vision of everybody driving an EV, so every parking spot a plug. One question that I had, what is the technical defensibility in your product?
Yes, I think we're talking a lot about technical defensibility. One major aspect is basically our optimization algorithm. The optimization algorithm has been developed as part of one academic thesis, and we're trying to patent basically the combination of hardware with the software, because of course the software itself isn't patentable. So that's basically one of the things that we want to really target and focus on. Does that?
On that, exactly?
Yes, sure, of course. So the optimization algorithm gets a few inputs. So it gets, for instance, the dynamic energy prices, the available PV that's, for instance, on top of the roof of a certain building, and also the connected grid, and also anything that the building, for instance, isn't using. So those inputs, as well as user inputs, such as the parking duration, so whenever someone plugs it in and puts down whenever they want to leave again the office building, for instance, we collect all of that data, as well as a lot of other data sets. And then we have a genetic algorithm, basically, that sets up this charging schedule. The charging schedule is a very highly dimensional schedule, and that's the reason why we chose a genetic algorithm, because that's the one that's really capable of handling this complex scenario.
I think you've partially answered to my question already, but like I will talk from experience because I do have an EV, and it's already adding a lot of stress into my life. It's true, especially when I have to travel long distances. One thing that is standard is when I'm parking it at my parking lot. Okay, why should I convert also this one into a subject of probability? That's my question.
Maybe can you repeat? So you already have a charger in
Yes,
place,
yeah.
and you're wondering why you want to integrate the solution.
Yes.
Okay, maybe we can use our backup slide. I'm showing our value proposition a bit closer. Because the problem that we started off with is that we have a limited connected load at certain buildings, especially old buildings. And if we look at our solution compared to conventional solutions, our main thing is that we are able to provide more chargers or more plugs overall. So if you're looking to really go with a conventional solution and you have, for instance, 10 chargers available already, and you want to supply or have 5 more at your location, that's going to cost you a lot because you don't have the connected load available. So you'll have to keep in mind that you have to basically build an entire transformation station required to increase this connected load. And all of that isn't necessary with our solution. So we have that reduction of costs, so the major cost savings that are huge, but also time savings. To really build a new transformation station costs 3 years, time-wise.
True. Yeah. Okay, thank you.
First of all, thank you for the great pitch. And I can speak in Claudia's words, the availability of charging is really an issue. Also on the tech side, a bit the question. For example, you mentioned ChargeX, a company which is also supporting the possibility with less power from the grid to balance it more. So where do you differentiate, especially in your first picture, your illustration, where do you difference not on the software side, what's the difference, what you do on the hardware side?
Great question. Maybe I can start with the software side and you take over the hardware aspect. So basically, what are our competitors doing? They're taking the connected load and dividing it proportionally to the amount of EVs available. So having a certain connected load, dividing it by the 10 EVs. That's not what we're doing. We're having this charging schedule that really differentiates at a 0.1 ampere level how much load each EV gets, basically, and that done over time. So basically, what you can see here is for 60 EVs, and from morning till midnight, for instance, we really say which vehicle is charged at what time, whereas our competitors, all they do is as soon as you plug it in, it gets charged, which often doesn't make sense, looking at dynamic energy prices, PV availability, etc. So that's what we all anticipate, take into consideration, and create this intelligent charging schedule.
Exactly. And then hardware-wise, as you mentioned, ChargeX, they're plugging the charging stations into each other, and then, yeah. broadening how many chargers are available. Whereas we have the central control unit, which really houses all the electric components that will be used, and then only the cables come off this central control unit, and with only plugs at the parking spots. Exactly.
So also a very lean hardware approach that we are able to supply here.
Thanks so much. So maybe building on this last question, from a user perspective, what does that mean? When I plug in my EV, will I have the optimal charge I want when I'm leaving? Or if I suddenly need to leave a little earlier, how will that affect me?
So thank you for the question. We're actually currently talking to our MVP customers, potential MVP customers. And we have some approaches where MVP customers are saying they want to enter how much the battery should be charged, for example, up to 80% to be more efficient for the more battery health saving, to say so. But there are also approaches where they're saying, okay, we're just going to charge it to 80%, you don't have to put that user input in there. And so they only need to put in how long they're staying. So there are different approaches depending on how also tech savvy the customer or the customer's employees are. Yeah, but that's basically what you would park your car, plug it in, either enter these metrics. For example, I want to have 100% state of charge of my battery at the end of charging because I want to go on a road trip, for example. And I'm leaving at 80 at 6 p.m. You could enter that, for example, and then that would be optimized. Or you could just plug it in and our standard data would assume you want 80% state of charge and leaving at 5 p.m.
And one thing that we also often hear in that regard is that people would appreciate to have it synced with their calendar. So just having your calendar really up to date and then taking those informations and using it for our charging schedule. But there's, a number of different approaches how we can get those user inputs, and that basically just depends on our customer.
One more quick question.
Yeah, I tried half an hour to find something to charge my car this morning. Yeah, anyways, so I can feel the pain point a lot. My question is, can you elaborate a little more on your go-to-market strategy? So whom are you trying to target when and how, especially for implementing the technology, the hardware side?
Yes, exactly. Since you mentioned the hardware side, I guess we can also start with our MVP, which we haven't mentioned what that really is. Since the overall charging unit that we want to build, the centralized control unit, is quite expensive. We need a lot of certification. We'll start with an MVP. So for our MVP, we will use a conventional charging station with a specific charging controller. And yeah, I know time is up. The charging controller is also the controller that we already use for our proof of concept. And this controller enables us to basically already use our smart charging schedule and do it with existing hardware in the market. And then our next step is basically going into hardware development. And that's our go-to-market within Germany then. If that answers the question, sorry.
Last up for this session, we'll have Albin. You have somebody digital? No. Thank you, thank you. And Tommy over there. Give it up for the Albin team.
I'm John Phipps, CEO and co-founder of Albin. I'm here to introduce my team and I's cutting-edge carbon capture and wastewater remediation project, Reversing Climate Change. The destruction of our environment is an issue that affects every single person on this planet. Human activity is destroying our sources of clean water. Meanwhile, the breakdown of our farming systems is rapidly raising the cost of living. Inefficient and expensive wastewater management from slaughterhouses, sewage, and drains are some sources of pollution our waterways absorb. This leads to harmful algal blooms, aquatic dead zones, and danger to people who live near these bodies of water. This picture on the right here is from Sydney Harbor just 4 months ago, unedited. Meanwhile, unsustainable agricultural practices have led to global fertilizer shortages, causing prices to double in just 5 years, threatening food security for billions. The result, a climate spiraling into instability. The problem is clear and the window for action is closing. Albin aims to solve the climate crisis by turning CO2 and wastewater into an affordable fertilizer. Algae naturally removes nitrogen and phosphorus and thrives in wastewater. We accomplished this with our novel photobioreactor that we developed at the beginning of the year. Since then, we've developed an upscaled pilot system that in partnership with the Canterbury Bankstown local government that we plan on installing as soon as we return from the Climate and Energy Prize. Its mission is to reduce the nutrient loads at our test site while removing carbon dioxide directly from the atmosphere. We grow a filamentous strain of algae to absorb these nutrients, capturing carbon dioxide directly from the atmosphere and using an AI machine learning model to monitor and manage its growth, maximizing yields. We accomplish this in several steps. First, wastewater is processed by our photobioreactor. Air from the atmosphere is then pumped through to give the algae its CO2 to consume. The algae that is grown is harvested and managed with that AI machine learning model to optimize those growth conditions and maximize yield. Our system is unique in that it optimizes exergy while making use of waste products, making our approach sustainable and low cost. Wastewater treatment centers and slaughterhouses produce methane, a potent greenhouse gas, as a byproduct of operating. We use this methane to power our pyrolysis process, turning the algae feedstock into biochar. The hot CO2 flue gas that's produced is then fed through our solar dryer to increase its efficiency before finally being fed back into our photobioreactor to promote growth. Algae is 50 times more efficient than trees at capturing CO2. Our process reduces atmospheric CO2, which is a major driver of ocean acidification, replenishes soil health by promoting soil microbial activity, improving water retention and preventing soil leaching, and prevents harmful algal blooms and eutrophication from happening in the wild, which is a major destroyer of aquatic ecosystems.
Albon operates a dual revenue model, combining biochar sales and wastewater treatment services to create a financially sustainable, high-impact climate solution. Albon's biochar is sold for $11 per kilogram, and with each system generating 36 kilograms annually, that's almost $400 in revenue per system. Each system also processes 300,000 liters of wastewater for just $380, providing businesses with a cost-effective solution to remove phosphorus and nitrogen from their wastewater. With these two revenue streams, Albon expects to cover our $1,300 system construction costs in just under 2 years. Albon plans to target two high-impact customer segments: agriculture and wastewater remediation. Albon's biochar will be sold to farmers, home gardeners, and landscapers looking to enhance soil fertility, boost crop yields, and improve water retention. Albon's wastewater treatment service will provide abattoirs, breweries, and water treatment facilities with a cost-effective solution to remove excess nutrients, reduce compliance costs, and improve water quality. By transforming industrial waste into a profitable climate solution, Albon is accelerating industrial decarbonization, transforming pollution into profit. Albon is currently making a real-world impact, starting with local council partnerships and scaling towards industry adoption. After engaging with local council members at a Cooks River cleanup event in Sydney, we partnered with Canterbury City Bankstown to deploy an upscaled pilot system at Wiley Park, targeting harmful seasonal algae blooms caused by fertilizer runoff. This milestone not only validates our approach, but also lays the foundation for our expansion into abattoirs and breweries nationwide. Albon plans to tap into two fast-growing, high-value markets: wastewater and fertilizer, projected to surpass a global $900 billion by 2032. Existing wastewater treatment is costly, energy intense, and relies on chemicals. Worse, it removes pollutants but fails to capture carbon. Albon changes this by integrating biochar production with wastewater treatment, offering a cost-effective, energy-efficient, and scalable solution that removes pollutants while permanently sequestering carbon, something that no competitor does. Traditional biochar comes from trees, slow-growing, land-intensive, and unsustainable. Albon's algae-based biochar is faster-growing and fully renewable, has high levels of nutrients leading to improved soil health, and is more efficient at capturing carbon. By leveraging algae instead of trees, Albon offers a scalable, sustainable, and commercially viable solution that achieves more impact with fewer resources. With just $6,000 in funding, Albon has achieved remarkable traction, securing a local government partnership and developing a photobioreactor for a fraction of the cost of competitors. We've maximized every dollar, proving our solution is cost-effective, scalable, and ready to grow. With the $100,000 MIT Climate and Energy Prize, Albon will be able to validate our technology and scale to serve multiple paid pilots across Sydney. This funding will be instrumental in securing Albon's future growth and position us well to secure a $500,000 to $1.5 million seed funding round. Climate change is the defining challenge of our generation, and without action, future ones won't stand a chance. John's background in environmental science and experience managing bioreactors, combined with my expertise in accounting and business analytics, equips us to scale Albon, both technically and financially. We've built a multidisciplinary team of interns, spanning biochemistry, engineering, and marketing. And our advisors include the Director of Australian Algae Research at the CSIRO, a corporate law expert, a customer experience executive, and an ex-engineer at Sydney Waters. With $100,000 of additional capital, Albon will be able to scale rapidly and expand our climate impact. We've proven what we can do with limited funds. Now with your help, we can grow. Invest in a solution that turns waste into value. Join Albon in capturing change.
Thank you.
Questions? Yes.
Mhm. Yes. Mhm. Yeah, completely. It's a really valid question. It's something that we've had to grapple with quite a bit, especially when a farmer's entire livelihood depends on year-to-year yields. Over in Australia, we have a couple of different avenues for breaking into the market, especially with farmers. Predominantly with on the biochar side of things, our nutrient levels sit roughly at an NPK of 315.2. So it's almost comparable with most chemical fertilizers. And some of the main driving points is long-term sustainable agriculture. So regenerative agriculture is really, really taking off. So obviously it takes some time to break into that market. But we have, there's the Murdoch, not the Murdoch. I'm blanking on the organization, but there's options in Australia for regenerative agriculture coalitions with companies who are interested in promoting regenerative ag that will subsidize some of the funding for biochar. But our plans on breaking into that market include offering free, low-cost trials with these farmers. In addition to that, the carbon that this sequesters isn't claimed by us. This is something that we offer to the farmers as an incentive program to adopt. Exactly. So this massively cuts down on the price that they have to actually pay for the total cost on what they're putting into the soil. Exactly.
We want to sell into the retail market because there's better margins there. So the $11 per kilogram is retail. So that's through the biggest retail distributor in Australia is Bunnings, which most people probably wouldn't know because it's only domestic. But they sell biochar for 25 Australian dollars. And our biochar that's Seasol, and our biochar, algae-based biochar has higher levels of nutrients than Seasol. So home gardeners, landscapers.
Mm-hmm.
So there's clearly a market for it, and they have stores throughout Australia. So if we could replace Seasol, that's very strong margins. And then we would transition eventually to sell wholesale. Margins are lower, but with economies of scale and with the potential additional revenue stream for farmers of carbon credits to claim, then it's a pretty strong incentive, I feel.
Having also worked for very traditional industry and very long CapEx cycles.
Mm-hmm.
Promise a 2-year ROI. So for the
Yep. I mean, to be fair, we haven't allocated all the overheads, so that's just comparing the cost to construct the system with the two revenue streams. There'd obviously be wages that we haven't fully budgeted in there. And we have made a lot of assumptions, but our assumptions are backed. So that we've got some calculations here. So if we were to service a medium-sized abattoir, that's 280,000 liters per day that we need to process. So then per year, that means we have to deploy 400,000 systems, which will cost about $500,000. Of course, yeah, there'd be overheads on top of that. But with the two main revenue streams being like 125,000 each, all of these are in American dollars. Yeah, it would pay off. We'd pay off the system in approximately 2 years. And yeah, the overheads wouldn't increase the ROI to beyond 4 years.
Yeah, and as far as geographic footprint goes, those 400 systems is still less space than a traditional aerobic lagoon. So typically speaking, a lot of abattoir infrastructure is not built to remove nitrogen. So with the customer interviews that we've done so far, this is a major pain point for them. They've already spent multiple hundreds of thousands in consultancy fees on how they can meet these frameworks lest they want to get shut down. So we did a very, very rough framework. This is all very conservative assumptions on prices. So typically speaking, abattoirs have a revenue, and this is small to medium, of around 50 million Aussie dollar a year. Assuming just the absolute lowest cost for each of the phosphorus, nitrogen, grease removals, and then the shipping off of these biosolids from like phosphorus precipitation, we came out to 781,000. Our figures are much, much lower than this annual cost of 781,000 per year that we're able to deliver nitrogen, phosphorus, as well as grease removal with our electrocoagulation process. And that biosolids removal process is also completely eliminated since we are turning that into biochar, which then acts as a revenue stream as well.
And just add on one more thing, the reason we were able to get the system cost so low is that comparing our systems to the $80,000 systems, we're purely focused on growing as much algae as possible. Quality isn't a main concern as it is for biofuels. For us, it's just about maximizing growing the most amount of algae as possible. And with our AI model, we're going to be able to maximize growth yields by tweaking all those inputs and yeah, basically generating as much revenue for as little cost as possible.
Thanks. Can you speak a little bit about the regulatory environment, particularly for the abattoirs and wastewater remediation? To what extent do they have a responsibility to clean the water that they're using, and can you talk a little bit about how how they stay within those parameters right now and what's not working for them?
Yep. So currently, the way they operate is with anaerobic and aerobic lagoons, and the way they're regulated is on a case-by-case basis, depending on how much land that they have to irrigate to. So if a abattoir has more land, they can have higher nutrient loads in the water. So if we go to the back to the money page, that one, yes. So nitrogen removal, a lot of them do actually just front the cost of paying the fines for nitrogen removal, but that clearly is not very efficient when there's obviously a solution that we can offer that means that they don't have to pay these fines. So when it comes to nitrogen and phosphorus removals, if year on year they're unable to follow these regulations, they do actually face being shut down, which is in Australia's case very good, just because a lot of farmers rely on these water sources, especially in the outback for irrigation water. So they are pretty heavily mandated in Australia. Obviously, this might change as we change legal frameworks and look to expand globally. But in Australia, we do know that the pressure is on them to make these changes, and we're offering the solution for it.
Can't say right.
Thank you.
That takes us to the end of our first pitch block. Another round of applause for our first 4 contestants. We'll now be having about a quick 15 or so minute break. Aim to return back to this room at 11:40, where we'll then begin our next panel and then pitch session. Thank you.
right now you have the chance. All right, so let me just do a brief introduction of who we have on stage with us today. On my left is Tobias. Tobias Gefelle is COO and Head of Strategy at SAP Sustainability. Next to Tobias is Philip Gerbert. He is the CEO of TUM Venture Labs, also director at Unternehmertum Applied AI. And one person further, definitely not last but definitely not least, is Livy Wayman, coming to us from MIT. She's works at Breakthrough Energy and is also a lecturer at MIT. So Libby, I'm actually going to start with you. Breakthrough Energy is a huge supporter of our ecosystem here, you as well, MIT as well, all the above. And my first question really relates to this prize, right? Can you give us some background on it, the value of it, and feel free to relate it to the course at MIT as well.
Yeah, absolutely. So happy to be here and so happy to see this global activity of entrepreneurship to address climate change and clean energy. Just really exciting ideas and amazing teams and entrepreneurs. So thrilled to be here. The Climate Energy Prize started at MIT in 2008, and that kind of grew out of a pretty nascent development on MIT's campus around interest in energy as a place where a very diverse group of innovators could come together to solve a lot of different challenges, including energy security, climate change, prosperity, productivity, and the interest in clean energy and climate change and energy innovation has really grown globally as the whole world is grappling with many of these challenges. But entrepreneurship is a difficult journey. So who here has been involved in a startup before working on the ideas that you're presenting today? Okay, a couple people. Who here has started a company themselves before the ideas we're working on today? All right, who here has raised capital to do that from the external community? Same couple people. Okay, maybe one person in the audience. Okay, so it's a very difficult journey. And we started the class at MIT because we believe that, that the skills required to take innovations that can address these challenges and scale them to commercialization, the skills that are required to do that are needed by a very broad community and can be taught and should not be held only by the few people who've done it before or who've been involved in something that's done it before. And so we started this class in 2008 at MIT to really teach a framework for what's required to identify world-changing innovations and then take them to market, whether it's through a corporate innovation and commercialization process or through a venture-backed or bootstrapped or by other means. All of the same fundamental concepts still apply, no matter how you're scaling them to commercialization. And as a result, we've seen dozens of companies, probably hundreds at this point, that have been formed as a result of these a framework that have gone on to raise over $1 billion collectively. The course teaches a curriculum and a framework, and then also sources innovations from MIT and other universities, puts groups together around those innovations, and the groups can then walk those innovations through the framework and the syllabus that we teach. And at the end of the course, the goal is that they have developed all of the kind of intellectual collateral that's required to frame their innovation and bring it to market. And we've been so thrilled to partner and support TUM's effort to have a similar class, tons of great background in innovations and culture and identity around innovation and entrepreneurship here at TUM, and it's just been a perfect match. And we've learned a lot through the process and are so thrilled to see the prize taking place here and to support it. So looking forward to growing this collaboration, deepening the relationship at TUM, and then also using this experience to grow this community globally as it already is and strengthen those relationships around the world. So thank you.
Thank you. And it was also the perfect transition to this course, because one of the learnings of the course that we had this last semester was the importance of AI. And so I want to address AI in this next topic here with you today, because let's do it this way. Philip, from your side, you're a climate expert, you're a startup enabler, you also did your PhD at MIT. Climate and AI, they're topics that you've worked on for a while, and now you're also very important in this ecosystem that we have here. Unternehmertum, it's been ranked #1 as a startup hub 2nd year in a row. And I'd love to hear from your perspective, what is unique, special, what is the value that you bring, or what this ecosystem brings from this side, and then also relate it to the AI topic if you can. So how has it changed over time, and why is that actually important? All the above.
It's a tough one because I can talk 3 days nonstop on either one. So first of all, I do have to say, you know, I'm really thrilled to be here because, as you mentioned, not only am I an MIT graduate, but I met my wife there, who's also an MIT graduate, who's now a professor at the TUM. So finally, we're really deepening the collaboration here. To your point, perhaps just quickly in terms of the ecosystem. So what we started with the TUM Venture Labs, building on Unternehmertum and TUM. TUM is, you know, very unique because it's an entrepreneurial university that wants to establish entrepreneurship as third pillar next to research and education. And we said, okay, we want to provide domain-specific supports to founders. And what is most unique in what we benchmarked, as I benchmarked MIT for a long time and so on, is that we have one organization. So we have one organization, the TUM Ventures are one organization with 12 fields. So what we excel in is really cross-field collaboration. So robotics in agriculture, AI in, you know, any kind of carbon capture, or additive manufacturing in building these carbon capture stuff, et cetera, right? Robotics. So perhaps just also, you know, we have, just to get an idea of the size, we have about 600 ventures overall in the pipeline, and we get about 2 billion plus of venture capital per year here, and about 75 founding companies founded per year, which is 1.5 per week. I think that's easier to remember. And I mean, it's in terms of energy and climate and resilience, I would say, you know, more than a third is related to this cluster in some kind of way across chem space, food, agro, biotech, mobility, built environment, and sustainability circle at all. So I think that answered a little bit, you know, what we are trying to provide. We are unique in that we have courses, like we were very thrilled with the TUM Climate Venture course, so on, but we accompany people much longer. So we have people 2 to 3 years that we accompany. So we are there when a student or a scientist comes to the TUM. You know, we're the entrepreneurial university. And when you leave, well, it's a little bit like Hotel California, you can check out, but you can never leave, right? So we accompany you till your IPO, and then we ask you to give back. So perhaps that's on that part. On the AI part, look, that would be a very long answer. Let me perhaps try to first say on climate tech, right? So we are in climate. I've been in climate and AI, actually both things, for 20 years plus. In climate, we have the problem that we are not going to achieve the 2% goal. And the problem that creates is that we're fighting on 2 fronts. One is obviously reducing CO2, climate action, and the other one is resilience. And many people have underestimated, because, you know, in Germany you thought 2 degrees more, right? I was born in Portugal, that's fine. Unfortunately, the biggest immediate effect we have is air flows, and obviously current in oceans also, they decrease dramatically. So we have these very long weather periods, and that is disastrous, right? And in many ways that you see immediately. So people just need a lot of money for resilience as well. So you have to speed up dramatically, and you have to be aware the money that was available so far might not be available in the future. People underestimate how much is going into resilience as well. And resilience is local, and people fight here. If you have wildfire in Los Angeles, if you have a flood here, you know, you see where people go. The relationship to AI is AI is almost our only joker in this fight, right? Everything else works against us a little bit, right? But AI is really an enormous accelerator, both of science and new solutions for building companies. We have lots of courses, you know, how you can use AI to build companies and so on and so forth. Obviously, some of AI also use a lot of energy, right? People exaggerate how inefficient it is because you have to always remember AI is about 1 million to 5 million times faster than your brain. It's about like speed of sound, speed of light. So yes, your brain only uses 20 watts, but that's about, you know, the equivalent of 20 megawatts that you could use for an AI if you calculate in the speed, right? But still, you see right now the buildup of AI at this speed, people are using horrible parts of energy because they cannot build up the renewables fast enough. In principle, it's no problem to have a data center that's totally carbon neutral. That's not what's happening right now, unfortunately, at the speed they're building up. But if you have that, then I think you cannot found a company today without leveraging AI to the maximum. Both of the company founding the things. And I think MIT is for us actually the most important partner. We work with MIT and Stanford. I have to say on AI, MIT is far ahead in climatetech. Thank you.
Thank you, Philip. Would you like to take this AI topic as well while we're on it, how you're leveraging AI at SAP Sustainability, also called SAP Sustainability its own form of startup, right? So how is it relevant for you and maybe for the teams that are in our audience here as well?
Yeah, thank you. I mean, if you think about it, yes, SAP Sustainability, which I'm representing here, we are 600 people at SAP, but I mean, overall, we're a 100,000 employee company and a 50-year-old startup, if you wish. So basically, we have been constantly disrupted since the foundation of SAP by Hasso Plattner and Dietmar Hopp, be it also at the front runner of new inventions like business process re-engineering, also cloud, and now it's also AI, right? So that's basically a stepping stone for us as a innovator, but also being disrupted at the same time. If you think about it, we have been architecting beautiful process flows and putting your eyes on it. And if you have an AI agent or you're talking conversational, you don't need all of that anymore. I mean, it's not so simple if you think about it, but at the end of the day, it's another wave of disruption. So how are we using AI at SAP? We're doing this in two ways. First of all, it's on our own operations when it comes to basically engineering new products. We can see efficiencies of 20–30% using AI tools, more digital ways of engineering, testing, speeding up also the time to market of new products. That's a major lever. On the other hand, we're also using it to reduce our footprint in the sense of making software more efficient, how it runs on the data centers. And we're also working with AI startups and climate tech startups to reduce the impact in the data center further. On the other hand, we're also using it big time to sell our solutions. Basically, you can't sell solutions without having AI embedded. And we also learned the hard way. Yeah? So maybe 2017, 18 was 1 year or 2 years with SAP at the time. There was the first big push on the former CEO, Bill McDermott. And I think if you think about it, fail early, fail often. I think that's what we exactly did. So we didn't do everything right. Yeah? So what didn't work out, first of all, it was more like a marketing push, but the product truth wasn't really there. I think we did not really do the right approach. And also it was a timing issue. Yeah? So it was pre the ChatGPT time where it was massive breakthroughs on AI that really change the capabilities, what you can do also in business processes. So we pivoted a couple of times on AI. I think right now it's a much more scalable approach when it comes to collaboration on the one hand with the big sales machine that SAP has, on the other hand, having a product truth behind it. I think formerly it was more like a research team that was disconnected with consultants and sales. I think right now it's really very scalable in the sense that we have a complete infrastructure around it. Also the availability of people that understand AI also, even in the consumer space, is growing rapidly. It's not only a niche application where you have a certain data scientist, but it's actually growing massively also in our employee base. So in a nutshell, for sustainability, we are experimenting on the agentic AI side. So having basically autonomous agents that can take complete business processes, orchestrate across different domains in the company. For instance, to speed up the way how permits are being obtained, also in the way how say product development is more climate efficient, and basically reducing the carbon footprint of new products, as well as more tangible use cases. I mean, if you think about our personas, like a plant operator or a chief financial officer, how can I make their life easier in terms of complying with regulation, or also boosting the profitability? So it's really about automating certain tasks, creating certain assets where there's an immediate value. Yeah, it was a very short return on investment, not only doing some magic analysis that will possibly help you some time, but actually automating certain tasks that create immediate value. So that's where we are going big time in. I would say all of our products have AI embedded now, but there's more to come, especially when it comes to agentic AI. I think that's really the next wave of innovation.
And also from Breakthrough Energy Ventures, so putting my breakthrough hat on, I'm an investment partner at Breakthrough Energy Ventures, and which also represents another great collaboration on this stage. Hasso Plattner is one of our limited partners and investor in the fund. And so we have a great collaboration with some parts of SAP as well. And we have seen AI in several different facets of addressing climate change, and several of our companies use AI for various things. Probably the most basic application of AI that we see companies already using is to speed up experimentation and kind of speed up combinatorial approaches to experimentation. And so this idea is not really that new. And so I think teams who are really working on material innovations, if you're not using some form of AI, we see that as kind of a hindrance and maybe would put you a little bit behind. And then another way that we see the application of AI is in image recognition. We've got, for example, one company, Sortera Technologies, that uses AI to be able to sort waste into highly recyclable streams at much higher value. So that's a great example of AI that is very specifically addressing climate change. What we're looking for next, and we're observing the scientific literature, is to see if the generative AI tools that have emerged that leverage text and information from basically the internet, if those can be used for material breakthroughs, if they can really be generative in going outside of existing databases and identifying whole new areas and spaces of scientific discovery. So far, we've seen that our companies that use AI in kind of the physical world really need around on the order of 1 million or so data points. And so far, the physical material databases really have like 10,000, 100,000 on the order, on that order of data points. And so we're not quite yet seeing those jumps that we would love to see, but this is an area that we're watching really closely and really could be the next frontier of AI to really address climate change through identifying new superconducting materials, new catalysts, things like that. So we're pretty excited about that area. And then we're also experimenting with the use of AI just in our own work to accelerate how we get our work done. So looking forward to tools like that as well.
Wonderful, thank you. Addressed in the panel multiple times so far is kind of the importance of the collaboration that exists. What brought the Climate Ventures course here at TUM, the prize itself. For the sake of time, I'm going to ask each of you, I'm going to push each of you to maybe give, if you're up for it, one concrete idea of after this prize, what's the next step? What can we do? What opportunities are there? And what opportunities are there for our audience as startups? Is there anything you can come up with on the spot?
Yeah, I guess a concrete step that all the companies here can take is just to continue the great momentum that the teams have shared so far in talking to as many customers as possible. Just continue to build those relationships, continue to be hungry for the feedback, and make sure you don't dive too deep just into the solution, but you're always connecting with the market. And similar that you're keeping your relationships open with people who can provide funding, whether it's on the investor side, grant makers, things like that. But just make sure that you continue to pulse the market, both for funding and for commercial feedback as you continue to develop.
And what about on your side, on the MIT or breakthrough side? What maybe can you think of something on that from that angle that could be a potential next step?
Sure. I mean, I think the participating in the prize is a great collaboration. And hopefully we'll, I know we'll see some folks at the finals. For Breakthrough, we're always open. We have a fellows program that supports very early stage innovators with some grant funding, as well as kind of development as an entrepreneur. And then Breakthrough Energy Ventures, we're a venture investor. We also start extremely early. And so we're always happy to continue conversation.
Wonderful, thank you. Philip or Tobias?
Well, look, we thought very carefully who would be the most important partners globally for our startups in this area. And we find, I think it's one ecosystem almost, MIT, Stanford, Breakthrough Energy and Climate, they're extremely interconnected, are by far the strongest globally. So that's why we put in a lot of exchange, and we have exchange programs, we have investment opportunities, we have, so to say, a tool exchange, et cetera, from which we can profit enormously. I'm not going to line them up, but, Contact Glass or the others, for all the things. And we have, very concrete interchange, both with Stanford, MIT, and Breakthrough. We're also looking very strongly at Asia jointly. Also, for us, Singapore is obviously, because of our TUM campus, the biggest one. China is the most important, but tricky in many respects and so on. And so to say, this kind of global, both for, in particular for Europeans, for markets, don't focus on a European market as a European company ever. I think, sorry, it might be unpopular, but just say, we are 8% of the global emissions, and, that's not where climate change is going to be solved ultimately. And that's not where the big markets are. And the other thing is, because European doesn't have a functioning capital market for any kind of first of a kind project, and even later for scale up investments, right now we need Anglo-Saxon capital, Asian capital, or Middle Eastern capital in. So that's why I think this exposure is also extremely important. We have an enormous interest from capital all around the world. So I think we're opening that up, but for them it's very important that you're also really addressing global markets. So that's the other thing that we want to achieve in this collaboration. Thank you.
And maybe also building on Libby's point, I think it's really pivotal as a next step to continue this customer centricity and product truth. I think you said it really well. In addition to that, I think what we learn ourselves at SAP, also sometimes the hard way, but also we see in a lot of our competitors actually in the climate space, is they need to be more focused on designing for scalability. So even when you're starting small, think about it, how can I set the foundation from a platform, but also product perspective, that I can really scale this? Can I also defocus on certain things that I give to partners or operators, so I can really focus on the edge that I have? Really with the 80-20 principle, so that at the end of the day, when you have your first 5, 10, or 100 customers, you don't have to do it in a consulting style model, but it's more like a factory. I think that's really important. From the SAP perspective, I mean, you heard it this morning from Tobias. There's various ways how we engage here locally with TUM and CEP. On the other hand, I mean, our standard model also in working with startups is to provide access to our customer base. I think we have like 70% of the Fortune 500 companies. It's a massive amount of carbon under management, customers that use our solutions, be it supply chain or financial systems. So we're always looking for differentiating features or partner solutions that differentiate our offering. And we have several programs actually to foster this. And there's specific startups, and I think we discussed with some of you in the pauses, be it on geospatial data or any area where we are basically not focusing on, that give us really an edge in our portfolio. That's where we can help you, and feel free to contact me or Tobias if there's a match.
And we can use this time now to ask any direct questions. So from the audience, is there anyone who might have a question for our panelists here today?
Hello, thank you for your comments and your insight. My question is concerning if you've noticed any patterns in the struggles that climate technologies have to scale. I think both from Venture Labs and Breakthrough Energy, it seems like you're working with quite a diverse set of industries within the climate energy space, and curious if there's any trends, again, patterns that you've noticed for scalability. Thank you.
So I've been in the space for about 20 years, and the tricky part on climate action, you're not going to solve it by software alone, right? As important as AI is and so on, you have to get your hands dirty. Ultimately, you want to wean the world off fire, right? Fire was a great achievement until it wasn't, right? So we have to get rid of it. So the trouble with this is normally you have really capital intensive scaling, right? And when you see, so to say, where companies fail, it's always on the same part. That's where the first clean tech wave failed. That's the big challenge with the second clean tech wave. And that's where we actually had an enormous support from Breakthrough Energy. If you were here at the TUM Sustainability Day, we had a whole session for all our scale-ups. What do you have to do to get a first-of-a-kind project, right? How can you finance it? Where should you do it? How can you go about it? You know, what are all the criteria you have to fulfill? And in terms of the challenge for climate tech, I find it always in this, you know, it's almost always you need hardware, or often you need systems, or even, you know, large systems. And, you know, how do you professionally scale? Okay. Particular first-of-a-kind projects and beyond.
Any other questions?
Thanks a lot for the interesting sharing. Last week I was in Harvard Business School, also visited MIT. Very interesting. My question is related with one startup from MIT. It's a very interesting one called tomorrow.io. So it's kind of AI weather or this data. So I want to ask Libby, how do you see these companies' development that they're serving from the, let's say, competing with traditional weather services agency, but they offer, you know, kind of B2B, but data subscription, and as well as, you know, customized solution. Basically, generally, how do you see this trend about AI in climate or weather? Thanks.
Yeah, we've seen a lot of concepts in climate and weather. Tomorrow.io is not a breakthrough portfolio company, and I'm probably not the most up to speed on that specific company, although, you know, I've connected with them previously. But we've seen a lot of companies that are using satellite imagery, for example, and other data sources in new ways, combining them using AI. There's another great application of AI that I didn't mention earlier, and figuring out how they can deliver new insights to different customers. So we've seen some, probably the most successful companies, just I've observed, maybe not, you know, holistically across the whole field, but maybe more anecdotally, have found ways to monetize those insights, probably through weather. And I think there's been a big push of, oh, you know, insurance companies must need this data. And I think people have struggled a little bit more in the insurance market. So it's really finding definitely the availability of data is a big kind of new opportunity. So in terms of like a why now, you now have satellite imagery that's much more abundant, lower cost. You're getting very low Earth orbit satellites that are now becoming available, and you have AI and more data. So there's a lot of availability. And then I think the question is like, what's the best business model? And I think we're seeing a couple of different avenues that way.
Let's just be clear. Weather is irrelevant for climate action. Weather is totally critical for resilience, right? So, and yes, we have, you know, the Data Science Institute, so we have the space, you know, we have an aerospace institute. There are tons and tons of startups coming up. I think they're fighting, it's not a blue ocean, right? Because Who is going to buy it? Yes, it's primarily insurance companies, right? Et cetera, et cetera. We have obviously other companies that are, for example, monitoring wildfires and so on and so forth in Canada, Australia, sort of from us. I mean, we're dominating that market actually if you're from Thomas, if you're interested. So there are lots and lots of, you know, resilience-related startups right now that are actually scaling very fast because resilience, and that's primarily weather-related because it's primarily floods, fires, droughts, right? That is a very fast-growing field.
Perfect. We're out of time anyway, so please a big round of applause for our speakers here today. I'll pass it back to the team.
Amazing. We'll just take a quick second to set up, but I believe the next startup on deck is CarbonTech. Let's take two to the judges, and two we'll keep on stage. So, do you want to take one with you, and then I'll give one to Nigel. Thank you. Nice. Just for the judges. Oh, thank you. Are you alone or is it hybrid? Okay, sorry. Okay. And here's the clickers. Perfect.
Okay, hello everyone. I'm Clara from CarbonTech, and 3 things about me are I love food, I love using data to streamline my everyday decisions, and I'm passionate about creating a more sustainable future. Combining these 3 interests, I often find myself at the supermarket wondering, does it really make a difference whether I buy this plant-based cheese or this dairy alternative? Today, I'm excited to show you how CarbonTech empowers producers of food and their consumers alike to answer these questions with confidence. Like me, and probably you, many consumers want to leverage their power to make more sustainable decisions in their everyday life. In fact, 56% of all growth in the consumer packaged goods sector comes from products with green claims. And people are even willing to pay around 10% more for these products, given that they trust how these claims are derived. But making green claims isn't as straightforward as it seems. With the rise in greenwashing, upcoming EU regulation will fine producers up to £2 million for unsubstantiated claims. And even when done right, understanding emissions with the use of traditional solutions like carbon consultancies can be too costly or inefficient, which further deters sustainable producers from leveraging this sales opportunity. CarbonTech tackles these challenges with 3 main wins. First, we found a consumer-friendly way to label products and have shown in our pilot study that this can unlock up to 20% untapped revenue. Second, we have a rigorous methodology that ensures transparent and accurate emissions data. And third, because we've automated our entire calculation, this allows us to charge only 10% of traditional solutions, which makes carbon labeling accessible to more producers. At the heart of our software lies a methodology that is not only scientifically rigorous, but is also compliant with all relevant quality standards like the EU Green Claims Directive. But we go even beyond that. For instance, in our proprietary database with over 100,000 granular data points, we assess the quality of each and every single one of them. And because our methodology is so transparent, we're able to track these metrics throughout the entire calculation, which allows us to assign a unique reliability score to all the numbers we derive. Despite all this rigor, we've streamlined our process, so obtaining verified green claims can be done in only 5 minutes. This is done by minimizing the amount of primary data we require from our customers. So they only have to provide us with basic product details like ingredient composition and mixing methodology, after which we're able to provide them with instant results. And in our optimized user interface, data can be viewed at a glance, but we also allow for data deep dives, such as benchmarking emissions and their breakdown against industry averages. From this analysis, we can then generate claims that can be placed directly on the packaging, which means the next time I'm at the supermarket, I'm now able to see that this plant-based feta has 50% fewer emissions than typical dairy cheese. This allows me to make an easy, informed decision as a consumer and sustainable producers to make more sales. With our solution right now, we're targeting small to medium-sized enterprises in food and beverage in the European Union, which is a market worth 5.6 billion pounds when factoring in the number of producers, their products, and our annual pricing model. Of these products, 19% are marketed as sustainable, which gives us a serviceable addressable market of 1.1 billion pounds. And in our initial rollout, we're targeting a share of 4% of this, which gives us a reachable market of 42 million pounds. Of course, in this largely unclaimed space, we also face some competition. What makes CarbonTech unique are three main factors that we've identified in over 100 client interviews. First, we have a proprietary database that we've carefully curated over the past 4 years, and that is specifically tailored to fill in typical gaps our clients have in their data. Second, we have a core commitment to transparency and accuracy, which is, for instance, highlighted by our patent pending reliability score. And lastly, because we've streamlined our entire process, we can give upfront assessment to clients, which allows them to have insights before they enter into any commitment. The development of our product so far has only been made possible by the complementary expertise of our core team. Marcia is an expert in climate policy and is in charge of strategy and regulation. Jasper uses his background in business policy to oversee operations and ensure scientific rigor in both data acquisition and methodology, while Leo and I form the basis of our tech team. His extensive expertise in the tech sector has allowed us to build a robust multi-component software. I joined the founders of CarbonTech early on in their mission with a background in computer science and psychology, which have made me identify that CarbonTech's approach is very much in line with what I believe is one of the biggest opportunities in the age of data, not only calculating more numbers, but importantly, also making them accessible and understandable to humans. With our combined efforts, we've been able to launch the alpha version of our product, which has already been tested in over 10 successful pilot projects, and we've been generating recurring revenue since the end of last year. Over the last 2 months, we've also been in active sales conversation with 22 more companies. This traction confirms that our solution not only resonates with producers, but also institutions like Greenpeace Magazine. In this pre-seed round, we're raising funds to obtain a third-party certification for our methodology and patent for our reliability score, and are continuing to work on our product, where we will soon release a beta version with advanced features and are planning to integrate AI for full automatization of data handling. By the end of 2026, we project to have a recurring monthly recurring revenue of 100,000 pounds, after which we will expand our scalable solution to other adjacent sectors, such as other fast-moving consumer goods and the fashion industry. Our aim is to be the global solution for product carbon footprinting and empower consumers in every decisions of their daily lives to make easy, sustainable choices. Right now, we're raising 500,000 pounds in this pre-seed round for the fundable milestones I just mentioned, and I'm mainly focused on accelerating product market fit and go-to-market strategy. To empower give our teams the necessary resources to achieve these goals, most of our funds will go into sales and product development. Thank you for joining us on our journey to make emissions data accessible with our solution that is powered by data and designed for human understanding. I'm looking forward to your questions, and thank you.
Thanks for the presentation. Could we spend a little bit of time on your revenue model and how that works?
Yes. So our pricing model is dynamic, where we consider different factors. Basically, we charge an annual fee that is calculated per product. And currently, we're estimating for smaller consumers around 15 products per client. What we factor into our pricing model is first, we charge in tiers, where clients pay per feature. The basic version of this is the version of our product that we already have live, which allows clients to enter their product data, submit it to our database, and receive basic insights, as well as an emission score. In our Pro model, which we think will be the most popular option, they will also receive deeper access to things like benchmarking and custom-tailored green claims. And then our premium version will have advanced features that will also follow from our AI integration. We also consider the size of the client, because we want to charge depending on the increased revenue that is generated on the product, and also make our solution accessible to as many producers as possible. So also support sustainable startups, for instance, with our solution. And lastly, we also factor in the number of products, which means if you have a lot of products, chances are that some of them might be similar, require similar research on our part, and have similar methodology. So we will charge less for this.
Thanks. And maybe one follow-up to that. So I understand kind of the driving force for a small business producing an alternative feta, for example, to adopt your product. But if they're going up against large incumbents who are producing, you know, a dairy-based feta, what is driving those incumbents to change behavior versus the status quo, and what's the cost of non-compliance for them?
So I think right now, focusing on consumer demand, claims like these is something that really would influence my purchasing behavior as a consumer. We've shown in our pilot study that sales can increase by 20%. So this is a great sales case, not only an idealistic pursuit for small startups. Yeah, and I think for them to enter the market as well, especially for alternative protein and dairy producers, this is a great opportunity to make themselves more visible.
Okay, thank you.
First of all, thank you for your pitch. I have two short questions. Did I get you right? Your USP or comparison to competitors, and also what you protect is your database, or what is the thing which makes you special in comparison to other startups using carbon tagging in different beachhead markets like you with the supermarket?
So the special thing about our database, we have a lot of secondary data that we get from research. So this is publicly accessible and should be. But what is special about it is, first of all, how we've curated over the past 4 years. And we've been in constant exchange with clients. What data do they actually need? To what extent do they have the data that they need to make carbon assessments for their full supply chain, for instance? So just the collection of this data, and then importantly, also the assessment of the quality of this data, which is not publicly available and depending on the scale that we developed ourselves. What we can actually protect by patent is our reliability score, which is this process of assessing the quality of the data points and then tracking it to also assess the numbers we derive from this.
Okay, second question, a bit provocative. If you really want to have a big impact on this, you have to scale like hell.
Yes.
What would be relevant to increase your scaling at least by the factor 10, better by the factor 100, or by the factor 1,000? That you not think about how I enter, I don't know, the German or the British market. How do I have, I don't know, 20% of the world market share? What would be relevant for this?
So I think for one, as traction will pick up, as our solution will be a demand maybe even posed by customers. So when sustainable products start having our labels and they're able to now benchmark against bigger companies, soon it will become a requirement for all the companies to make their data as transparent, just from the consumer side. And then also, I think our approach is very scalable in a very sustainable way, because we have a very clear idea how we're going to scale. So what our strategy is in this regard. So right now we're focusing on enterprise in the EU, small to medium sized, and that produce food and beverages, just because their methodology and the data they have available is very similar. But because we've built this database and this process up so far, any new methodology that comes in, any new factors that we consider, for example, for US producers, we can easily integrate into our models.
Maybe last question. In terms of the database and the reliability score, I think one of the key problems we also see from SAP perspective is, cracking this LCA at scale approach, basically with AI and other tools, making this from a very manual process, something that can really scale, going down several steps in the value chain if it's a fabricated product.
Yes.
How do you crack this? And also, I saw also on the premium side, you're giving consulting. I think that's typically a showstopper for scale. So how can you also do this consulting based on benchmarking and other things in a more productized way?
So for one, for the consulting, right now we're doing this manually, and we have a bunch of pilot projects that we've tested this in. So not only understanding emissions data, but also improving emissions. We've shown in our pilot project that we can give suggestions to increase emissions up to 40%. And this is a use case that we definitely see for AI, because it basically depends on making hypotheses, testing it, clustering data, observing patterns in the data, and developing an intuition about it, which is something artificial intelligence would be really useful for. So this is one use case where we see this. As for the assignment of our reliability score, We have a semantic interpretation of this and default values that the data enters our database in. So for instance, for now, with the primary data that we get from the clients, receiving a score of A would require them to sign a declaration of truthfulness. So basically saying that this is data we're very confident in. Whereas if they want to receive excellent quality, they would need to have some external proof like their electricity bills. And for the secondary data, which we research ourselves and which we enter into the database, we also have a semantic interpretation of how to assess this.
Thank you again to Carbon Tag. Next up is CEP. Here, let me set them up in the link.
All right. Hello, everyone. I'm Sparsh, the CEO and founder of CEP. And our vision is to build a world where everyone has access to stable, clean energy. Just 4 years ago, I faced a blackout that changed my life. Growing up in a small town from rural India, me and my family experienced a week-long power outage. From just outside my window, I could see a dangerous mess of wires, with people from the nearby slums rushing to tap into these electrical wires just to get an ounce of electricity. And yet, there was none. When I asked my dad why we couldn't just install solar panels in response to this power outage, his answer was really simple. We don't have the space and we can't afford them. And that moment struck me. If a middle-class family like ours couldn't afford access to renewable energy solutions, what hope did the millions of others have? And this challenge extends far beyond just my hometown. Over 700 million people worldwide lack access to reliable electricity supply, with over 200 million people in Southeast Asia alone, many of whom live on less than $2 per day. And despite the promise of renewable energy solutions, even in regions where they are existent, they're often too expensive, require a lot of land, or are too inefficient for our needs. We need renewable solutions that are truly scalable and are truly accessible. So I made a promise to find a better solution, and that became the thermal floater. The thermal floater is a device that can convert the heat from the sun into electricity very efficiently and cost-effectively, all while floating on water bodies. These devices use the concentrated power of sunlight and convert that into electricity. Each of these devices about 540 watt hours in a single day. Not only that, these devices are also very compact, so you can connect multiple of these devices easily in an array for very easy deployment and scalability. And just to put this device's efficiency into perspective, let me give you an example. Take an example of a typical 3-bedroom apartment. A 3-bedroom apartment would use 11 kilowatt hours of electricity every single day, all which can be powered by 3 solar panels. But if we were to power the same house via thermal floaters, we can do it in 1/3 the area. And these numbers are backed by the research and simulations that we have done over the years, proving how efficient our thermal floater devices can be. And we have also done research in material science to improve the conversion efficiency of these devices. But what excites me the most is the potential of application for our devices, where there's a huge market for floating renewable solutions like ours. And initially, we want to target the regions where these devices can be implemented easily and perform at their peak, like in the Asia Pacific. But soon, we want to expand into other growing markets as well, like the Middle East, North America, and Europe, all of which have a strong financial backing and high adoption rates for technologies like ours. Among all of these regions, we have garnered a lot of traction through awards, but what really matters the most is our validation and a letter of intents from companies like Zalora and Raffles Ecogenics, who want to pilot our devices in Singapore. Not only that, we are also in talks with some of our main customers, who will be the power grids and the energy utility companies and the governments, like Tata Power from India, Telge Energy from Sweden, and Sunseap Renewables from Singapore. We'll be a B2B company leasing directly to them for leasing directly to them for large-scale deployments on water bodies. We'll be leasing the thermal floaters, but also help them with installation and maintenance of these devices, as well as the expertise to keep it running smoothly over the years. And in just 10 to 15 years, we'll scale to the point of seeing a measurable reduction by impacting over 20 million people and helping offset 480 megatons of carbon dioxide every single year. Not only that, in the process, we'll be saving billions of dollars for the power utility grids and the governments. While other solutions like solar panels exist, they inherit all the limitations of traditional solar power. The thermal floater is built fundamentally different. It maintains peak performance in extreme heat, delivering triple the energy density of any of its competitors. Not only that, it also has the potential to be one of the most affordable sources of renewable energy at 33% cheaper prices than solar panels. And it's really easy to deploy and maintain that people could do it without much technical knowledge. And we have made this because we understand the needs of energy poor communities. I have lived the problem that we are solving, and our team combines expertise in renewable energy, material science, business policy, and we are advised by leaders who have had previous experience in founding companies, who have had previous PhDs from MIT, and have mentored teams at the MIT Sandbox. We are also advised by leaders who have had previous experience in founding companies and raising from top VCs. Together, and over the years, we have worked with our customers to figure out the main pain points in this renewable energy industry. And what started as just an idea to solve it, we have turned it to simulations, proof of concepts, and prototypes. And now we are wanting to pilot these devices in real world conditions to test out how they perform in real life scenarios. And we are currently filing patents to protect our start to finish solutions. Currently, and in the upcoming years, we want to start commercializing these devices from Singapore and then slowly expand towards Southeast Asia and then scale up production all within the next 10 years. But just to commercialize in Singapore, we'll need a total of $4 million. But even before that, our very next step is to scale up production to pilot and deploy at a very small scale, for which we'll need $250,000, of which we have already secured $150,000 through grants and awards. And your support would help complete our funding needs to reach pilot deployment and making this dream a reality. I'll end on this very sobering statistic. Energy poverty still remains as one of the leading causes of death in the world. In the past 7 minutes that I've been talking, 30 people have lost their lives from these conditions. Deaths that were preventable with access to clean energy. We have a good idea, a good pathway to get to our vision, and a good team. But we'll need your help to get there. And I hope all of you will be with us on this journey to make energy poverty a thing of the past. Thank you.
Thank you for your question, for your presentation. Very well done. Well, I had a question. What is the core of the intellectual property and why is it defensible?
So most of the materials that we are using that convert our heat directly to electricity. Those materials are the materials that we have researched over the years. And those materials and the combination of the materials that we use can be protected via patents as well as trade secrets. Yes. So our main competitors are not really the solar panels, but rather the floating solar panels. Our main competitors is the floating renewable industry. We want to deploy these devices in water bodies, like the reservoirs, rivers, ponds, freshwater water bodies. And our main competitors would be all the floating water companies like Wave Energy, Tidal Energy, floating solar panels will be our main competitors.
Thanks so much. Just a clarifying point. So if the premise of the business is to tackle energy poverty, how are you ensuring affordability for your consumers? And if you're replacing floating solar, are you then not servicing utilities rather than the end consumers that you're trying to reach?
So we want to the best way to get into to serve these energy poor communities is to partner with the businesses that already have operations in these areas. We are partnering with companies like Tata Power, who operate in villages in these areas. And these villages have access to a lot of water bodies where these thermal floaters can be deployed in easily. And that pond or lake would power the entire village or where they deploy it in.
Thanks for the great presentation. Also, maybe staying with your chart that you have up here, where do you see the cost curve of the thermal floater developing? I mean, you're basically competing with solar PV, which has like 20–30% cost reduction on a kind of a semiconductor curve. How is it going to look like in 5 years? Are you still going to be out of the curve?
So, so these materials, right, they again scale with economies of scale. Right now, each of these prototypes costs about $8,000, $6,000 to $8,000. And with economies of scale, because the materials that we're using are also a form of semiconductor. So with semiconductor technology, you can utilize existing machines that are used to manufacture solar panels, that are used to manufacture the diodes for solar panels, and use existing technologies and retrofit those machines to produce our materials at a large scale.
Could you elaborate a little bit more on the business model? You said sales and maintenance is going to be your focus. Is this not, is both maybe not a little bit too much or too tricky to implement, talking about the scales that you're talking about?
Yeah. So mainly we want to start with leasing the thermal floaters, but we want to help with installation mainly. But maintenance, not every customer would opt for our maintenance, because these devices are really, we have made these devices so that these are very easy to maintain. So there's not a lot of technical knowledge that we need to impart on the service team for them to work with these devices. So the technical curve to get to maintain these devices is very low. That's why we could easily train a team to work with these devices and maintain them.
I have one additional question. On terms of production, how do you see a value chain to produce your floating solar panels with scale?
So we mainly want to integrate our technologies with the semiconductor manufacturing technologies. We are currently partnering with universities and manufacturers in Taiwan, the biggest semicon hub in the world, and we are starting to manufacture the materials at a large scale currently. So we want to partner with companies and manufacturers who already have the expertise in this area, as well as other manufacturers for other parts like our lenses. We are partnering with companies in Japan who already have the expertise in manufacturing such lenses at a large scale. And each of the components here used in a thermal floater are protected by our patents, like the lens, the design of the heat sinks, and the casings. So we work with manufacturing companies who have similar experience with similar products and build a supply chain ourselves with the help of their existing knowledge.
So this is a kind of a prototype, or can you give us a feeling about the size? And if you
this is the exact size of one model.
One model. And okay, if you scale it now, how you will put this in a row? Will you change size? How you will interconnect them all together? How you will bring this energy to the grid, or whoever is the
Just to
user?
give an example of how these devices would be connected, each of the devices would be connected. Each of these cells, we call them cells or modules. Each of these modules can be connected together using the ports on the sides. And from one array, we can take out the power from the ports itself. So we can take out the power from one array, from one port of these modules, and then we have an offshore power grid, or an onshore power grid, where we use wires, just use seabed wires or like floating wires to convey that to the grid nearby, onshore or offshore.
And what is the minimum number of those modules you need until it makes sense? How much you need a minimum?
So at 1 megawatt scale, it's 18,000 modules. So to make sense at a large scale, because customers in renewable energy generally buy in terms of 1 megawatts at a very large scale. So we can use 1 megawatt as a typical reference scale, and scale in terms of like 18,000 units, 18 to 20,000 units.
Okay, I have some more product questions, but I think we're running out of time. Thanks. Yeah, okay, they have 30. Oh, no, I think you want to ask a question. So if you take this number, and how is it arranged? Is it like a string, or if one module fails, what are you doing?
So each of these modules can connect to similar modules nearby. So these modules can also convey data. So whenever one of these modules fails, we can convey through the data port that this module which is between like these 6 modules has failed, and we can take out these modules just from the top. Our next iteration of these modules can be just taken out from the top in an array. So replace them. Yes.
If one fails, is it still running or
Yeah,
not?
the other modules around it are still running.
Okay. So it's not in a string. Good.
Yeah.
Thank you, Incitec. Next up is climatetech. Another round of applause for climatetech.
Good morning, everyone. So I'm not here to preach, but I'm here to give a story. Imagine having to work 8 hours just to go and sell your produce and selling them at a price which is lower, which is 70% lower than the actual value of the product. I have worked that 7-hour walk in the sun just to sell the produce because there is no power to refrigerate your produce. Ladies and gentlemen, climate change has made the situation worse. Here is a highlight from the news broadcasters, how this is affecting millions of farmers across Africa and in my country, Zambia. For example, last year, about 50% of the planted arable land was lost due to drought. And the country is seeking $900 million just to have the growth. Zimbabwe, Malawi are facing the same challenge. Ladies and gentlemen, allow me to introduce you to Mary, a 30-year-old farmer whose food production is affected by climate change. She lacks resources to adopt climate-friendly initiatives, and she's not even connected to the national electricity grid, and about only 10% of the country is connected to power, and millions of others are facing the same challenge. How are we solving this problem? We are using digital and connected technology, IoT, to transform how farmers get access to solar energy solutions through a pay-as-you-go model and providing access to climate financing. But how are we really doing that? So we have designed a microcontroller unit that is used in the manufacturing of solar panels, which enables us to sell these clean energy solutions on pay-as-you-go basis, and the farmer or the user is able to access the performance and the efficiency of this solution through a mobile app. And they're able to make direct repayments just by using the mobile application. Some of the products that are using this microcontroller unit are the smart egg incubators, including the smart water pump for drip irrigation. You can scan the QR code and be able to watch the product demonstration and the feedback from the farmers on the ground. How is it working? So for example, a farmer gets a product on credit, such as a smart solar water pump. The farmer makes a micro repayment using mobile money, and the pump automatically unlocks and begins to work. Through a mobile app, the farmer is able to monitor and able to control the pump using a phone, and the farmer also is able to access weather data and warning, and the cycle repeats itself. And based on the payment history, by using machine learning model, we're able to calculate alternative credit score in order to provide them access additional climate financing. And so far, we have unlocked climate financing worth $5 million in collaboration with our partners. So we are targeting SDG 2, 9, and 8 by promoting productivity, promoting access to climate financing, and also promoting climate adaptation and resilience. And by working with 1,000 farmers, we'll be able to save about 500,000 liters of water and able to save about 200,000 tons of carbon emission. We are looking at the total market of about 10 billion US dollars, that is across Africa, with immediate target about 1 billion US dollars by targeting our country, Zambia. Some of our competitors include SunPower, Mysol Hompa. These are not just our competitors, but also our potential partners. I'll get to explain how we become partners. So what makes us unique is we are using our proprietary microcontroller unit, and so far we have a provisional patent. And we're also using alternative data to implement an alternative climate credit score, additional finance. And we're also recycling aluminum to make the solar panel frames from the aluminum cans. So we're so far piloting with 200 beneficiaries on about 200 hectares of land, and we have more than 100,000 farmers on our wish list, thanks to our collaboration with our partners, that is the Ministry of Agriculture and the United Nations. So our revenue model includes the sale of clean energy solution and also licensing our microcontroller unit. One of our partners is HomePower, who has given us a letter of intent. They sell solar panels, and it's a Chinese company, and they're willing to be using our microcontroller unit in their sale of the clean energy solution. And our profit margin lies between 20 to 25% on scale. This is due to including the social inclination of our product. So we need about $50,000, and this money seems little, but because of lack of scarcity, we have been able to control our cost by using a first principles method, by being able to reduce our cost of production. And we need to use this money to acquire industrial electronic assembly equipment for surface mounting soldering, and also to purchase a delivery van in order to improve our logistic capabilities. Because so far we have about 4,000 hectares of land waiting for us to save. Meet my fellow co-founder who has expertise in industrial engineering. I am a student of computer science, and we are outsourcing additional support from some of our partners, which include United Nations, Asari, Ministry of Agriculture, Mulime, and this provides us additional expertise, allowing us to focus on the core services of our startup. If you are passionate about SDG 9, 10, and 13, please join us as we empower farmers, combat climate change, and build a sustainable, brighter future without leaving anyone behind. Thank you.
Thanks a lot. So drip irrigation, solar panels, and an electric pump. Who owns the hardware?
We own the hardware.
Okay, and you are providing the hardware to the grower. Who does the maintenance of the hardware?
So we do the maintenance, let at a fee, but are also partnered with extension officers provided by the Ministry of Agriculture, who are able to offer additional maintenance support to the beneficiaries.
And in how many years are you expecting to make the money of your investment back and start becoming profitable?
We are profitable.
After the investment of providing the drip irrigation and the pumps and the solar panels.
So within the space to 6 to 10 months. So usually what happens is most the farmers, out of the 12 months, they would only farm for 2 months because of lack of infrastructure. But with the provision of this solution, they're able to farm throughout the year. They're able to sell at the right price, and they're able to increase with the capacity. So it means that their revenue doubles, and they're able to make actually payments between 3 to 6 months.
Thank you.
I would have a question on your team. So you're 2 persons right now. If you would continue now, what you need, where you need the help? Is it more for developing the product, or is it more for stronger reach out to more market customers, X, Y, Z?
So the most need that is for scaling in order to access more market. So with the support from UNDP and Mulimi, we are able to access additional expertise through outsourcing. So the reason why we are two of us also is because we are looking at when we were starting, we never had enough resources to be able to hire the right talent and able to join our team at the right price. So we needed to find this support by working with the accelerator labs that were able to provide this expertise.
Thanks so much. My question is on farmer pre-qualification and onboarding. So prior to building a credit history of the farmers that you're targeting with your platform, how will you vet the farmers that you're choosing to include and ensure that you avoid creating a debt burden or over indebtedness for farmers, which we've often seen in kind of ag tech solutions in spaces like this?
So we are analyzing the mobile metrics. For example, these farmers buy airtime, they buy bundles, and they use their phone for calls. So we are using this metric data to be able to analyze their credit score, and they also use mobile money. So that data we're analyzing, and also we also look at the additional metadata such as, does this person have a family? Do they have children? And what we have seen is someone who has a family, someone who has children, have low default rate than a young man who is single, who can easily run away and switch off their phone. So all this metric data is what we are using to be able to analyze the alternative debt. And so far, we have more than 90% success rate.
Have another one.
So maybe a question on the value chain perspective. Also, as the next step, where do you see yourself specializing? You mentioned also outsourcing certain things. I mean, basically right now I understand you're doing both the app, you're purchasing the hardware, you have the hardware development and assembly, and then also the operations and delivery van and so on. Where would you do basically the first, I mean, where do you see a main differentiation point, and what are things that you might be able to let go of?
So the main differentiation point is the hardware, because currently we don't have any solar manufacturing company or any hardware company in the country. So what we're doing is we obtain the monocrystal and solar cells, connect them in series and parallel, and able to recycle the aluminum to make the solar panel frames, and able to recycle plastic to make 3D filaments in order to make the node of the panel. And by doing so, we are reducing the price of the solar panel, and also the module, the microcontroller module allows us to also supply this module to other solar panel suppliers across the country. Like I said, we have a letter of intent with the largest supply of solar panels. So it means that it allows us also to generate revenue from the hardware. So the main is the hardware.
What is the role of the Ministry of Agriculture? How do they support you, this partnership?
So the role of the Ministry of Agriculture, number one, is to provide access to the market. They have more than 500,000 databases of farmers. Secondly,
but how do they do it concretely right now? So are you like collaborating with them, and have they given you access to something, or is this promises that
no, they have given us access. Okay. And also they have extension officers in the deepest and remotest part of the country. So we have access to this network of support, and we're able to utilize them, and they're able to provide us some of the maintenance work at no cost.
Thank you. And that takes us to the end of this session. Another quick round of applause for all three startups. And now it is time for lunch. So lunch, I believe, will be in the cafeteria on the second floor, so just up this staircase. In order to get lunch, you need to make sure you have your name tag and display it. I believe this is your access to get in, so please don't forget this. And then we will be reconvening in what, 45 minutes, is that right? Or at 1:50, so. For one, sorry? Okay. Yes. Please enjoy. I mean, I think it's join us for one. We would like a picture take with Libby because she has to leave. Maybe you saw it. That would be nice. That would be nice. Yeah, Lacey, I might just call it. Maybe I have not clue where somebody is right now. It might be in a call.
Ting.
A little bit more? Here, wait, I got an idea. Still on the side. We're going now. Okay. I think that's good. That'll turn.
Not hiding them, they're just in there.
So we have how many mics do you use? Five. You got your scripts? Last page.
Great. We'll just get. Hello? Hello?
You're done.
Cool. Hello, everyone. I think almost everyone, right? Sure. Hello, everyone. My name is Alejandro. I'm a PhD student at MIT and one of the other co-managing directors for the Climate and Energy Prize. Hopefully, you all enjoyed some lunch, and really excited now to look at this next panel here. I'm going to introduce Anna once again, who's going to be the moderator for here. She's playing multiple roles here, and she's going to introduce the rest of her panelists. Please help me welcome Anna.
Thank you very much, Alejandro. I'll welcome both of our panelists up to join me as well. This will be a spotlight on Proxima Fusion, the startup of Francesco. Here we go.
Thank you.
One.
Sit right there.
Yeah.
Shall we sit?
Please. Yeah. Yeah, I'll slide through. Cool. Maybe slide in just in case the camera. All right, we're getting cozy. All right, wonderful. So the second panel now will be highlighting Proxima Fusion Francesco Shortino's.
Nicely pronounced.
Very cool. Startup. And we also have VC perspective from Benjamin here. Coming from UVC, you've been there since 2017? Yeah, maybe. So we're excited to have this dynamic for all the startups here who would like a little insight on another startup that is maybe a bit more advanced, a little bit, couple years of more.
It's still just 2 years.
Ahead of you guys. So really take the opportunity during this Q&A to ask them your questions. And yeah, with that, I know we are looking at a lot of pitches today, but I'm going to give you the opportunity to pitch your startup now.
Cool.
And let us know where you're at, what your current status is as well. That'd be great.
Just a couple of minutes.
That'd be wonderful.
Okay. Cool. Great to see everyone here. So my name is Francesco. I'm originally from Italy, studied in the UK and then in Switzerland, then in the US. I was in course 8 at MIT back in the day. Did my PhD in fusion, specifically a kind of magnetic confinement fusion device called tokamak, which is the most conventional way of trying to fuse light atoms, forms of hydrogen, smash them really hard together, and then get them to 100, 150 million degrees. And when you do that, you reproduce the process that fundamentally powers all the stars. So what fusion research is all about is trying to basically build a star in a laboratory. And if you manage to do that, you get to effectively limitless clean energy with no long-lived radioactive waste. The kind of thing that you would like to have, let's say. So after MIT, I joined the Max Planck Society, actually here in Garching, 10 minutes, I think, in that direction. And I did some research again on tokamaks, was one of the European coordinators for tokamak research. And then we spun out with a group coming together from here and from Greifswald, where there is another part of the Max Planck Society. And we started talking about QI stellarators as a much better solution. We came together as a team from the Max Planck, MIT, another co-founder was also in nuclear science engineering at MIT, and from Google X in California. And we started really beginning of 2023, hence why actually the first day we were in the Munich Urban Collab here in Munich was April 17th. So we haven't yet hit the 2 years mark, but we're now 75 people. We have raised about 30 million in private capital, about 35, 40 in public funding. And we're based here in Munich, in Zurich, and in Oxford. And we're trying to build stellarators for power plants, which sounds like an insane thing to do, but we managed to convince some investors to actually finance part of this at least. And yeah, it's a moonshot of first class in the sense that really, if you manage to do this kind of thing, you change the way we think about the world, the way you produce energy is so fundamental to how everything else in society works. Maybe I pause it there and we go to the questions afterwards.
I can give you a little bit more time. You also had a big event earlier this week. You also have on the scientific side of things and the research side, the publication that came out. Feel free to take a little bit of time and share this with our audience.
Super,
it's all about you, right?
Okay, so 2 weeks ago, we released a peer-reviewed journal publication about a stellarator power plant design that we call Stellaris. And the big claim that we made in that paper is that we have designed for the first time a coherent concept, a design that takes all the physics and engineering constraints of a power plant, so not of an experiment, a system that can produce 3 gigawatt thermal of power, or about 1 gigawatt electric. And the special thing about the Stellaris publication is how we really bring all the disciplines from physics, plasma physics, thermal engineering, neutronics, electromagnetism, all of it in one place. We got that done with a team that, the saying in startups, jump off the cliff, build the plane as you go down. We really started in 5. And we originally said to Benjamin and other investors that we were going to be able to do that with a team starting with 5, scaling to 30 people over 2 years. In practice, after 1 year, we were done. We're also more than 30 people at this point. And so that's been, the Wall Street Journal quoted the head of the MIT Plasma Science and Fusion Center saying that was the single most important thing that happened in fusion in the past decade, which was very generous, but we'll take general statements. And so that was a big thing. And then a few days ago, we opened a lab here in Munich, in the area of Mittersendling, for those that know the city. This is a 1,000 meter squared facility, 10,000 square feet, give or take. And it's actually as large as the Wendelstein ZBNX stellarator, which is the most advanced stellarator on the planet, which is the big beast in northern Germany, where we take a lot of our inspiration from. So we're not a software startup. We sounded like a software startup for a long time. In fact, we talk a lot about simulation-driven engineering and how we can iterate on hardware much faster if we have software systems integrating all the pieces of the story. That requires taking all these multiple disciplines and really bring all the right people in the room with a smart kind of framework. And I can go in lots of detail there if anyone is interested.
Thank you and congratulations. Would you share with our audience a little bit about your journey? So you grew up on a hazelnut farm in central Italy, right? From a student to researcher, researcher to startup, maybe if that's the progression. Where'd the ambition, the passion come from? How'd you get into deep tech? And also, you mentioned it a little bit already, but the key people that supported you along this way, because maybe it would be insightful for our audience too. That'd be great.
So I didn't come from an entrepreneurial background of any sort, but I had the bad tendency of signing up for universities that were very entrepreneurial. And so I did my undergrad at Imperial, and I was one of the physicists that didn't want to hear anything about any startups. I just really wanted to be at peace with my fusion. But somehow I was forced into it to some extent. Then I went to EPFL, also a very entrepreneurial place, but again, I was happy with my fusion. Then at MIT, Philip, you were in the theory department in course 8, and I was shocked when a theoretical physicist in condensed matter theory, at some point we were doing a teaching assistantship together, and he said, at MIT, everyone is an engineer. I was like, are you a theoretical physicist? I counted on you on throwing some crap on the engineers. Instead, MIT is a fantastic place where everyone is trying to build stuff one way or another. That got a little bit in my brain. While I was at MIT, a company spun out from the Fusion Center called Commonwealth Fusion Systems, and goes as CFS in short. And CFS today is the largest fusion company on the planet. They have raised more than 2 billion. They're building really big things. Actually, within 2 years, we expect them to show 10 times more energy output than input in a tokamak, which is what I used to be doing research myself on. By seeing the CFS story, let's say, we got to all see in the fusion ecosystem that if you put together the right kind of team and you have a view on what are the tailwinds and how you can accelerate beyond the linear path of fusion being boring, a little bit of progress all the time. If you can have a claim that there are a few things that can really kick you up and make the prediction of how fast you can go basically impossible, then you can actually change the course. So I joined the Max Planck Society, and I was still in Fusion Land, still caring just for, I was very happy with my topic. But then I got to Munich, got to see what more of the Max Planck Society's advantage in stellarators, came to understand what W7X, this stellarator in Greifswald, what it really means. And that was an eye-opener. So while I was in tokamaks, my co-founders, Jorit and Jonathan, were in Greifswald, where W7X is. And basically we started talking, and I accepted that what I was doing was not the right thing. And this, I think, is quite rare. People just admitting that I didn't do it easily, I should say. I complained a lot and I was pretty stubborn. But if you meet my co-founder Jorit, you would accept that he's more stubborn. So that helped. And eventually we agreed a QI accelerator was an opportunity. It was able to use the same tailwinds in high temperature superconductors, so very powerful magnet technology, and simulation as the one thing that speeds up the most and that allows you to change the way people work. We took these two things, then you can add additive manufacturing, you can add another number of things. However you look at it, there is no way to look at what we're doing and not accept that there are massive accelerations happening. And so that's how I didn't want to be an entrepreneur early days, but it just had to happen. Let's say it had to. There was a need of entrepreneurial vibe, which you feel here at Unternehmen TUM. So I think entering in the Unternehmen TUM Venture Labs network helped us to build that entrepreneurial vibe and step out a little bit from the very research-oriented Max Planck Society vibe. So we were the first spin out in our institute of the Max Planck in 60 years of research, which basically means there are no startups in the Max Planck Society. There is now, this is happening, and I think it's partly happening because Unternehmen TUM and this ecosystem is just giving, there is a voice in everyone's back saying, you know, you could actually do something a bit different. And that's how it happened for us.
Thank you. Bringing you, I promise I didn't forget about you. Now that, because you're one of the supporters of Proxima Fusion and Francesco, and in this deep tech field, it's something that there's often long payback periods, right? So it takes a little bit in this tech environment. And I'd love to know from your perspective, what was it about the team? What was it about Francesco that caught your eye, that made it interesting for you, that, that made it the reason for why you said, okay, I'll commit to this, I'll invest. And maybe if there's criteria or something along those lines, that would be incredibly useful. Thank you.
Yeah, thank you. I mean, first of all, I think it's very important that Francesco is in the center of this because he has the really amazing story to tell. Well, what's the center of our decision to partner with Proxima? You mentioned long payback time. So when a startup is coming around the corner and discussing fusion, the usual reaction is, fusion, that's a technology that's always 10 years away. I know it for 40 years, 30. So, and the fund lifetime, so of my fund is 10 years. So within 10 years, I need to build a company and make it as attractive that someone sees value in it and wants to buy shares in it. So that's usually where the conversation ends, right? But at the same time, VC is, and actually every investor is driven by a combination of risk and return. So I fundamentally believe that capital is going anywhere. So wherever there's opportunity, you will find it. And if not, change the opportunity. But that's a very efficient market. And with fusion, you just have to be aware that the opportunity is just huge. You know, if you look at the list of problems and challenges we have, low energy prices are on the very top end of things. They touch into peace. They touch into independence, into sovereignty, into wealth. So, and everybody in this room has gone through an ideation process and looked through, hey, which problem do I want to solve? And actually the problem that Proxima addressing is one of the most relevant I can think of. Now, coming back to my daily job, and that's taking, so my product is good decisions, yeah, and future is uncertain, of course, but the ultimate decision to invest in this company is that despite all the risks, accumulating all the factors, there is a fair chance to achieve that situation, that we can show the world it's possible to create clean, cheap, safe, abundant energy. And this possibility alone inclines so many chances that it's worth taking the risk. And now let's look back to the risk. I mean, the risk is that we could achieve it, but we're not doing it. That's the real risk, right? And so I think the factors that Francesco mentioned, that it's possible, combined with the passion, the drive of the people, and also scientific confirmation that it's possible. I think there's no one in Europe or in the academic group who's not backing up what you're telling, more or less. So these many elements together give a fair chance that we can succeed. And if that's possible, you have a feeling a bit like, you know, other companies that started similarly. When students walked into our door, or driven people say, hey, we have these skills, we have that idea. And you think, oh, that's a tough call, but years later it's possible. And that's, you know, that's worth going down that path. And so, you know, hopefully in a few days, we will see a rocket launch from Munich. And we got a lot the same question. Well, a successful rocket launch is if it doesn't blow up on the platform. Yeah, let's be clear about that. But it's a bit, you know, we got many questions around this as well when it started. Hey, why do you give students 500 or 5 million euros to build a rocket? Yeah, because maybe a few hundred million euros later they will fly to space, and Europe has access to space again. So, and it's worth it, right? So long answer, but the fundamental reason for the investment, and it's not only us who decided to back this team. I think it's half of Europe who's supporting this company, is that there's a unique combination of ability, drive, and especially opportunity and problem to solve.
Adding to that, I think this view on what are the things that actually matter is what drives us. So we talk a lot, so it's unsurprising that we agree. Maybe one focus specifically on fusion. An important element of the story is what happened in 2022 with W7X going into full operation and some scientific publications showing that we're not battling with physics as much as with engineering now. And that, I think, is an important part of the story. Can you take a long-lasting problem and turn it into an execution and engineering problem? If you're battling with whether something is physically possible, that's a very different kind of problem, because you can't accelerate discovery. The best way to accelerate discovery is fundamentally you put smart people in the room and you give them enough coffee. You can't really do much more. As opposed to, if you have an engineering problem, you can actually put it on a roadmap. You can think about supply chains. You can make a budget. Which,
yeah, we need to do it more detailed.
But you can give it a try. And that's important. And that's really the enabler to putting fusion on a venture capital timescale, because you can actually plan.
Just to comment, because it's such a beautiful example of what we're trying to achieve. So we're with deep tech startups, we try to do two things. A, reduce the time and cost it gets. And the key levers are AI, simulation, and often additive manufacturing. And then to leverage non-dilutive funding, which is, let's say, often relevant. And I was most impressed how accurate the simulation was in Wendelstein 7, right? I mean, that's kind of now the big question I would have for you, lots of engineering stuff, you know, what would you say are the two major hurdles still in Stellarators on the engineering side, so to say, where there is a specific milestones where you say, look, this is really something where we still have the core uncertainty and, you know, that determines our time frame. Sorry.
Yeah. So the first one is magnets, demonstrating magnets that can go to much higher magnetic field intensity compared to what we have on W7X or any other device. That's the key engineering risk that we are tackling head on. We're going from W7X having 2.5 Tesla at the center of the plasma to, in the Stellaris design, 9 Tesla. Fusion power scales with, if you remember one formula, scales with the magnetic field to the power of 4. There are very few things in nature that scale with the power of 4. There is the black body radiation and nothing else that really comes to mind. So that's the kind of power law that you need to chase. So whatever you can do to increase the magnetic field by 10%, you get a massive reward. So that's the one enabler. The fact that those magnets with high temperature superconductors became possible over the past decade, and now there is a supply chain that is global for the key materials. We don't have to make them ourselves. That's important. That's one enabler. The second one relates to tritium, the heaviest isotope of hydrogen. And either you find a way to make it abundant by some magic, or you have to design your own way of making tritium. And that's currently low technology readiness level. So in the Stellaris design, there is a design of a system that makes tritium self-sufficiently. And the claim is not that we're done with the work, with the R&D on that topic, but that there is a wide class of designs that are compatible with all the other requirements and that this is feasible. So we're not claiming, the claim of the paper is not that the work is done, but that it is feasible, it will happen. And now the question is, how long, how much, and who's gonna do it?
You have an answer to those questions?
What?
Do you have an answer to those
I
questions?
have some answers on the magnets. So we're working on magnets.
He pitched them to me, so he has them.
So the magnets are definitely feasible, and we're 2 years away from making the most advanced magnet humanity has ever seen here in Europe. The tritium-related things, we showed a plan, let's say, a possibility in the Stellaris paper. One reads that paper and might think that that's the product of Proxima Fusion. That's what they are building. That's not the right interpretation. That is a feasibility, compatibility display of the most conservative sort. We're not very conservative people, so we are not actually doing that. We're just showing that if you decide to be very conservative with the tools that we have, we can prove to you that you should be quiet and let us do our job. But there is a better world. So we have a baseline, and now it's time to go up, let's say.
I'm going to ask one more question relating to this dynamic that we have here on stage. In the beginning, I asked a little bit from Benjamin, his perspective of why he supported you, but what was it from your side that said, okay, from my side or from our side, from the team side, this is a good fit too? Because it's a two-way, it's a match that goes two ways, right?
So in our case, we got to know Unternehmen TUM via a friend who also happens to work at Unternehmen TUM, Niklas Maus. And Niklas made the introduction to the head of the CEO of Unternehmen TUM, who then raised the flag, these guys are talking something weird, and somebody should really check them, and that somebody better be good, because this is going to be a bit difficult. That's how Benjamin came in.
What stage were you in at that point?
Pre-seed, pre-seed. So we were we had the team together. We were saying we can do all these tough things, and Benjamin was one of the people, the first person maybe, who was being a bit more exacting, a bit more demanding in terms of planning, not overdoing it. I don't think we needed at the very beginning. This is maybe a good thing for startups in the early stages. I personally don't think that one needs to have full-fledged detail and full business plans for absolutely every scenario. You just need to know that you have the path and that money will be well spent if you are given that money, let's say. So we connected for us, for a startup in Munich, working with Unternehmen TUM is pretty obvious, let's say. Unternehmen TUM has a really an unbeatable advantage. There is a building downtown with 400, 500 people, I don't know, who help you do anything. So in the German ecosystem, broadly, they are the organization you want to work with. We also, in the pre-seed, we had this combination of working with UVC partners and Pluro, which is London-based. And so by the combination of the two, we had operators in different geographies going across Europe, helping us bridge also into the US for more capital. That turned out to be pretty good.
Amazing, thank you. Do you want to add something, or should I open it up to the audience? Because we've got between 6 and 7 minutes.
Just adding maybe one moment on this notion, what do we need at seed stage? So I think the fundamental investment decision on my end was taken after I met all the founders in their natural environment and was convinced, okay, these people have the skills to do what is on these 5 relatively not beautiful slides I saw. But you know, the problem and the path to solution was very credible, and the next building block that connected was the ambition and also the conviction of going all the way. And you know, you have that spontaneous effect of you meet people, what they say, and if that picture is consistent to what they actually do over a long period of time, that is something that truly convinces me to go into a long-term partnership. And by the way, it's things that also go into the culture of the company. You know, there are founders that negotiate with their investors 20 months period vesting schedules because for whatever reason, Proxima has a culture of, hey, we're in for this in the long run, has totally different regimes that are just optimized for the success of the mission. And you know, this combination, it was really striking.
Thank you. All right, we've got questions here.
To my knowledge, there are about 40 odd private companies at the moment, and I guess that was a major development over recent years to attract private money. It seems that many of them are trying to position themselves as they're the only player, as in, you know, a supply chain view. We want to build the system that you just laid out so well. Is there an underlying belief the winner takes it all and that has to be the case, or do you expect that we are not far away from a stage of maturity where you will expect more specialization along that supply chain to be built?
So yeah, there are 40, 50, depending on how you count, fusion companies on the planet. $8 billion raised so far. And the largest is Commonwealth Fusion Systems, which by itself took 2.5 or so billion. There are also supply chain companies that are being created specialized on fusion. That number, 40, 50, does not include those. There are companies that are specifically being built to make big microwave sources and tritium handling systems, which you can't sell to anyone other than those 50 fusion companies. So that creation of specialized supply chain is happening. The ideal situation is that there is no such need, because if you depend on vacuum vessels, the ideal situation is that the vacuum vessel that you need is the same as the particle accelerator, and that CERN is subsidizing much of that technology. And for most of the technology that's in fusion, that's the case. Public projects have created that supply chain. That supply chain is particularly strong in Europe, by the way. Of the 50 fusion systems companies, let's call them that way, I would define those as the ones that are trying to be integrators. Those 50 are the ones that are after the biggest, clearest moonshot. So you can think of it as a hierarchy. There is the companies that are trying to build the power plant, the reactor, so the burning core, not necessarily the plant systems. So not the switchyards, not the cryostats, not the cryo plants, not just the burning bit that Siemens Energy would need to work with, let's say. And then there are the companies second tier, let's say, that if no fusion company succeeds, they don't have any customer, just to be clear. You need that combination, let's say. There is no reason to think that there will be a winner take all. I personally think that more and more over time, we're seeing this geopolitical positioning. So there will be one likely European fusion champion. There will be one or two US fusion champions. In China, it's very clear. It's a company that is publicly backed, as it tends to happen. So this positioning of a few winners has happened in China, has probably happened in the US. In Europe, it's happening, and that's what we're there for, let's say.
Hi, Francesco. For an early stage technology which is in its research phase, how do you think about the techno-economics when you are talking to your investors, and how do you in fact even imagine your technology at scale? And are there any tips for early stage founders who are in the very research phase today?
Good question. So when we started out, one of the assets of Proxima was my co-founder Jorrit, who was doing his research at W7X, and his entire research topic was scaling the W7X experiment to power plants. So we were able to go to Benjamin and say, we have actually full detail, the most advanced techno-economic analysis of its kind on the planet, and we can show what those numbers are. And then let us tell you where all the uncertainties are, if you have the patience to go through all this level of detail. Eventually, that level of detail is good to understand sensitivity, let's say, but focusing on the details is not useful when your product is fundamentally a decade away also. So I think, you need to be able to see that there is wide margin for opportunity. You need to know that the famous question from venture capital is, how big is the market? Okay, if it's small, no point in creating a moonshot-like startup. Then you need to know that there are multiple ways in which your thing could be an explosive success. If the techno-economic tells you that you have a 1% margin on some engineering component, then you might be in trouble. But in the case of fusion, our techno-economic analysis tells us straight from the code, in good faith, tells us that we could make energy at 1 cent per kilowatt hour. I take that number and I put it in the trash because it's very unlikely that we have the level of understanding of all the systems, because in practice, operations cost money. Maintenance of the devices takes money. Give it a factor of 3. We then went to venture capitalists and we actually added a factor of 5. And that is probably because we were too conservative. In practice, you learn soon in startups that you need to do some marketing. So instead, you go and say, you put a factor of half in most cases. We did the opposite. Yeah? We said, if we don't start this with some integrity and some understanding of uncertainties, we'll get in trouble. So the statement is not that we know what the price of fusion energy will be, but that we know what the opportunity is. And that, I think, is a very different kind of stance.
And I think actually the question is great because it taps a bit into being humble. And why is that the case? We're doing an amazing story, an amazing technology, but bottom line, it's about bringing a lower electricity bill to the household of your grandma in Europe. Yeah, that's bottom line the mission. If we're not succeeding there, this whole thing, these events, it's pointless, right? And you must not lose that out of sight, that it's a pretty commodity product. It's energy as cheap as possible, as fast as possible. As Francesco said, you need to have a right to play in this, and it's cost in the end. So, but VCs are also a bit like this. So if there is enough margin in it, it's good to go.
Well, thank you. Thank you, Anna, for leading such a great conversation with Francesco and Benjamin. Please help to thank them. Thank you so much. Sure, please, thank you. So we'll keep another mic here for the judges. Mic there. Sure. We'll just give one of our judges just a few seconds. Did everyone get a chance to get some coffee before this? No? We'll promise to give you some before the deliberation. Absolutely. No worries. Great. So now we're moving on to our last block of startups. Please help me welcome to stage Liftoff.
How do you envision urban transport in 2050? Reflection of humanity's collective thoughts, ideas, and vision predicts the rise of urban air mobility. Electric taxis decongesting roads and autonomous drones enabling fast last-mile delivery. All of this is possible with a technology that I'm going to present to you today. When you open up the news, you will see engineers of our time work on electric flight. And they make quite some substantial progress with the first passenger flights planned by the end of this year. However, they all struggle with one fundamental limitation, no matter being it drones for cargo delivery or eVTOLs, electric vertical takeoff and landing aircraft for passenger transport. They struggle with the battery. Lithium-ion batteries are inherently limited. In order to understand where this limitation comes from, we need to take a closer look into the underlying structure. If you zoom into the cathode, the place where we store the lithium in order to store energy, you will find a layered-like structure. And you will see that this structure is full. There is no more space for lithium. We've reached an upper energy density limit. Besides, you will also find oxygen. Oxygen can react violently with the electrolyte that can cause the battery to catch fire, something we've all seen in the news before. Lastly, they require on critical metals, such as nickel and cobalt, that strain the supply chain and make the cathode the by far most expensive component of the battery. Lift-off Technologies rethinks the way we store energy. A seemingly small change, substituting oxygen with fluorine, with dramatic implications. By having fluorine present in the structure, the chemical structure is different, and we can now store 5 times more lithium than before. Besides, the metal fluoride bond is extremely strong. The materials are stable up to 1,000 degrees Celsius, which makes the entire system inherently safer. Lastly, we only require abundant materials that can be sourced from a domestic supply chain, which is particularly important in the current political climate. Lift-off batteries are lighter, safer, and can be scaled. And the implications for the electric aviation industry are transformational. If you look into the requirements for a battery in different electric aircraft type, you will see a distribution like this. And with lithium-ion batteries, we are able to electrify small drones. With lift-off batteries, we're going to be able to electrify larger drones, eVTOL, and regional, even narrow-body aircraft. We identified the military drone market as a beachhead market opportunity for 3 simple reasons. First, military drones desperately require lighter and safer batteries, and they are very willing to pay a price premium for that. Secondly, it's easier to build smaller batteries for these drones because they're not that big yet. And thirdly, we have existing relationships with the US Army because of previous academic collaborations that will help us to leverage and gain them as a customer. For the military sector, we plan to expand to commercial sector because the volume is bigger. The ultimate end game, though, is electric aircraft, eVTOL, and narrow-body aircraft designs. At this point, it's very important to emphasize that once this technology is matured, you can put them everywhere. The application space is virtually endless, ranging from heavy-duty vehicles to maritime transport, decarbonizing container ships, or even edge AI application. We need to run novel AI models in a spatially confined space, such as a humanoid robot. The impact on the climate is substantial. The aviation industry emits almost 1 gigaton of CO2 every year. If we don't do anything about this number is going to rise to 1.9 gigaton of CO2. With lift-off batteries, we're able to electrify all of regional and 70% of narrow-body aircraft. That allows us to collectively save 7 gigatons of CO2 by the end of 2050. Our innovation is based on academic research. Over the past 8 years, we published our results in academic journals and protected our innovation with a patent. We then went and demonstrated upscalability. We built larger prototypes in pouch cell formats. We are currently in a preparation phase, conducting customer validation and participating in prize competitions and exhibits, and soon to start fundraising. By this summer, we plan to enter the product development phase with milestones developed by techno-economic modeling. After these 2 years, we're going to enter the production phase to generate early revenue to fuel a healthy growth. I'm going to lead the development of lift-off batteries. I've studied these materials over the past 4 years in my PhD at Oxford Universities, and I've studied other types of batteries at TUM and MIT and ETH Zurich before. I also do an MBA at the moment, and I have experience as a strategy consultant and venture scout. My partner in crime is Mauro Pasta. He's a professor at Oxford University and serial entrepreneur. He has founded 3 battery startups in the past, 2 of which have been acquired. And there's Dominic. Dominic has experience working for an electric aircraft company here in Munich before founding his own battery safety startup. He's going to guide us on battery safety testing. Lastly, there's Schumann. Schumann has experience in critical minerals, is analyst at the International Energy Agency, and will guide us on the battery supply chain. Together, we want to move fast, develop batteries for electric flight, and make ChatGPT's wildest dreams become a reality. Thank you.
First of all, thanks for the great pitch. I would honestly have two questions. First one concerning your tech and a bit the view in the future in comparison to other solutions we see in the battery market. How would you compare those?
Yeah, so you mean comparing to other batteries. So this is a good overview of what existing batteries there are and what next generation alternatives there will be. I think the most sort of direct competitor of this would be lithium sulfur chemistries. They rank fairly similar in energy density wise, around 700 watt-hours per kilogram. The key differentiator is, so first we can exceed these numbers with second generation, even the third generation version of these batteries. But the key differentiator is the safety aspect. So the chemistry that we're working on has this advantage of not being prone to a thermal runaway as a result of lacking the oxygen. And lithium sulfur struggles with safety consideration at this point.
Thank you. And a second thing, as you might know or not, we have the honor now to start similar like the Venture Labs, an incubator for whole Germany to boost the battery translation, because there was a lot of money spent in research and now we want to translate it. And we look on the whole value chain, and we with Florian here in the room. So everyone who's interested, he will push this thing forward. I have a question. If you look on the whole value chain, how do you deal this with your solution concerning the possibility to recycle it? Is this possible?
Recycling? Yeah, I mean, recycling is mainly driven by the costs of the materials you can extract. We don't use any critical metals at this point. So we haven't really looked into the recycling aspect of this chemistry yet. Conceptually, it will be, a similar configuration as we have in other types of
Also with the fluoride in it, like you explained.
Yeah.
Concerning the reactions they have.
Yeah. So yeah, I mean, from a process point of view, it will be a similar way. You have the same cathode, electrode, anode structures, and the processes you will develop for conventional chemistries should be also able to extract, the metals from the cathode. But we haven't really looked much into the recycling aspect.
Honestly, Florian pushed me in the direction. Are you happy with the answer? Okay, thanks a lot.
Thanks for the great presentation. Maybe two quick questions. One, where do you expect to be cost-wise? I mean, we're below $100 at the cell level for the conventional lithium-based cells. Again, it's about safety and density, but like, is it a factor of 2 or 3 or 4, just by order of magnitude? And then from the business model, are you going to stay in the cathode space, or you want to go all the way for the battery? And is this more like a licensing business for like a BASF, or you want to be a manufacturer?
Yeah, so starting with the costs, so we did some modeling to try to understand how cheaply could we produce these cathodes. And we came up with numbers around $60 per kilowatt hours. That is mostly because we don't have nickel, we don't have cobalt in there that drives the costs up. Obviously, that is assuming, everything runs smoothly at economy of scale, but this is sort of the, the number we conceptually can achieve. So definitely competitive with existing and with next generation alternatives. In terms of where do we place from a go-to-market strategy and producing so there are various aspects where you can enter the value chain. Right now I was talking mostly about the cathode. The point is, you can only develop the cathode in combination with an electrolyte system. That's kind of where the magic is happening. So the plan is, after we demonstrated these milestones that I was talking about before, when I set up a small manufacturing line to produce these cells and sell the entire cell to the beachhead market opportunity. And from there, we plan to look into joint ventures for mass production. So I think the past, couple of years have shown us that it's not easy to scale up battery manufacturing, and you need players and people that know how to do it. So starting with a small manufacturing line that can be controlled, that can be done. My co-founder Mauro Pasta, they did it with Cuberg. They sold cells in a small manufacturing line. It's definitely possible. Scaling up to gigawatt level, gonna have partners in a joint venture.
Yeah, I have one question then. So you talk about a lot of electric airplanes. What do you think that needs to happen before your material, so your batteries are up in the air transporting people?
Yeah, so there is quite a, kind of outlined way of like certain certifications you need to do in order to put a battery onto an aircraft. There are guidelines, there are safety tests. That's why we put safety in the center of these milestones. You need to be able to demonstrate that they don't fail, they don't start catching fire. There are a number of tests you need to do. It's mechanical, electrochemical, thermal tests. These need to be tested, demonstrated they are safe, validated externally, and then can slowly work together with the operators and then put these cells into an aircraft.
Third time? Yeah, thanks also from my side. I have a question on the team composition. You showed that one picture. Are there any students involved as well? And are you all doing this full time, or what is the let's say the level of commitment of your founding team members, since they all have very high positions already?
Yeah. So I'm currently a student. I'm still doing my MBA. Yeah, so I'm going to be doing it full time. And then the Mauro Pasta is going to be a co-founder and they're the advisors on there. The plan is to expand the team and get people on board that know how to build batteries. So the next steps is to build pouch cells, multi-layer pouch cells. And it's actually not that easy to build these. So we need people with experience. We plan to hire cell engineers that have done this hundreds of times and have the experience to do that, to demonstrate and produce that.
Thank you. Next up, we have Reduce CO2. Please help me welcome them to stage.
Okay, thank you very much. And my team and I would like to invite you to our search for the Philosopher's Stone, where the legend says the Philosopher's Stone can transform a base metal into a precious metal, like gold, or in our case, transforming CO2 emission into the modern black gold, graphite. And to explain why I'm comparing gold with graphite, I would like to ask you a question first. What do you think, how much graphite is in an average BMW i model, one of the fully electric cars? Especially within the lithium batteries of these cars. Most people actually assume that lithium is the main component. However, it is graphite. And together with other components in the car, it sums up to around 98 kilograms for one single car. And graphite is not only critical for the electric vehicle battery industry, but also a lot of other new green industry fields are dependent on graphite as one of their raw materials. And this is the reason why we're actually facing a significant supply gap in graphite already by 2030. And this supply gap will only increase further. And it's assumed that for Europe alone, this supply gap or the demand for graphite will increase by 500% until 2050. And we're not only having this supply gap, we're also having a strong dependency on one single country as the main provider of graphite, which is China. And this is also the reason why the European Union identified graphite in the recently signed Raw Material Act, not only as a critical raw material, but also as a strategic raw material. And this is where Educo comes into play. We developed a process that can produce a green synthetic graphite with high and flexible product properties that can be produced independent of the location. And in general, synthetic graphite is nothing new. It already exists on the market. And it's quite often produced by the so-called axion process. However, this process is associated to different environmental as well as health risks, and is emitting around 10 tons of CO2 per ton of graphite that is produced. The Reduco process, on the other hand, is actually consuming around 3.66 tons of CO2 per ton of graphite that we produce. And the only byproducts that we have are water and a little bit of surplus energy. And this is possible because we're actually utilizing a process that occurs in nature and recreating it in our reactors. To explain this a little bit better, I need to introduce you to one specific rock type first. It's called a pegmatite. And pegmatite are characterized besides other things due to their huge crystal size, as well as enrichment in raw earth elements. So here, for example, you can see one individual spodumene crystal that is around 11.6 meters tall, which is huge for an individual crystal. And this is possible because it's formed during a very late stage of magma differentiation, where we have the release of a hydrothermal fluid. This fluid is enriched in volatiles, such as water and CO2. And if it's then penetrating a reducing environment, like a shale or schist, for example, we have this natural formation of the massive graphite deposits. However, it is a natural formation, so there's quite a variability in the quality of the graphite. And to reach the quality that is necessary, for example, for the electron vehicle battery manufacturers, they need further purification steps, which is emitting CO2. And of course, it is a natural formation, so we're dealing here with a fixed location. We now want to recreate this natural formation of graphite in our reactors and upscale it to an industry scale. And the only products that we need are green hydrogen as well as CO2. Here we want to focus on point sources at the moment, but in the future, it would be quite interesting for us to also find corporations with companies who are doing direct air capture. And with this, we can produce a graphite where we have a high control and flexibility of the product properties, so we can adapt to different requirements of different customers. We're having a flexible location, so we can go where we already have the infrastructure, where we have the green hydrogen production, or where there is a huge CO2 emitter. And our production is truly carbon negative. And we achieve this by following a 3-stage process, whereas every stage is occurring in one individual reaction chamber. All the reactions that are occurring in chamber 1 and 2 are widely known and often already used in the industry. Our innovation is then in the 3rd chamber. This is our growth chamber, where we're imitating the really final last step of the natural formation of graphite, but without all its negative downsides. So this is where we're transforming at the beginning, CO2 into the green synthetic graphite. And this places us in a quite advantageous position compared to other competitors on the market who are dealing with a fixed location, having this huge variability in the quality of their product, emitting a lot of CO2, using cost-intensive catalysts, or dealing with the official regulations due to their environmental as well as health risks. And at the moment, we are focusing on the electron vehicle battery manufacturers as our primary customer, who would be interested in the highest grade of graphite that we can produce. And the steel and lubricant industry as our secondary customer, who would be interested in the little bit lower grade of graphite. And assuming this, as well as constant energy prices and decreasing hydrogen prices, we should have a positive revenue as soon as the first real production unit comes online. Which brings me directly to our roadmap. At the moment, we just handed in the patent application of our process and are now in the phase of attracting strategic partners, secure soft funding, and the official incorporation of our company, which will then be followed by the next 2 big milestones, which will be the process optimization and scale validation, as well as the building of a pilot plant to test the Reduco process under real circumstances. And with we, I'm referring to myself, Lotta Terniten. I'm the analytical geochemist in the team, Stefan Pitsch, our experimental geochemist, and Andreas Hetman, the environmental engineer, as well as our 2 advisors, Anil Theti for the business side and Andreas Jallas for the mechanical and technical side. And you probably recognized on one of the first slides, there was a little graphite crystal. And this is just for you a visualization to have a better feeling on how fast these graphite crystals already naturally grows in these pegmatites formation. So at the beginning of the talk, we had this little crystal on the left side, and over the 7 minutes, it multiplies its size. And with this, we hope to spark your interest into Reduco, the modern philosopher's stone, who can transform CO2 emission we are so worried about today into tomorrow's most valuable resource, graphite. Thank you very much.
Thanks so much for the presentation. A quick question on the risks associated with your feedstock. So there's a lot of innovation and startups working to kind of bring DAC and green hydrogen down the cost curve. Is your cost base and your cost curve dependent on those companies kind of succeeding at their aims? And is there any risk that that delays your ability to bring your costs down?
So far for the DAC, I can say pretty fast no, because we want to focus on point sources anyway.
Yeah.
So there's a clear answer. For the hydrogen, that's our bottleneck. If we use green hydrogen, it's still very expensive, and projections have been delayed already. I think in the market, it's not a question when affordable green hydrogen, or yeah, it's more the question when it comes, not if it comes.
Yeah.
Our process is not depending on green hydrogen. We can use any hydrogen source. We just lose the green graphite in that equation. But from our market research, we know that actually it's not the green graphite that's the most interesting part. It's being more independent on China. So that's something that we can, yeah, that we are okay with trading off for a bit. But we want to go back to the green graphite in the very end then.
Thank you.
Can I have a quick follow-up on this? So even if you cannot rely on green hydrogen, then would you still claim environmental benefits based on the conversion process, or?
Sure. So we showed that slide that the Exim process, it emits around 10 tons of CO2 per ton of graphite. If we use methane, we come out with like 0. So we are not net negative, but we are still a lot better off than with the current process.
What's your exposure in terms of commodity prices? I mean, do you basically assume like a higher, more rare commodity and a higher price? And second, is there also any dependency from a regulation perspective in terms of regulation on the extraction process?
Okay. So for the first one, we currently calculate with market prices there are so far. We have in our business plan so far planned out for 40% of the highest pricing. The rest should go to industries like lubricant, for example, which don't need that much high grades. We hope that we can tune that process a bit more towards the higher end of graphite for sure. But yeah, we have talked to customers and they have told us they are willing to pay like a bit extra for the green labeling, especially also for being more independent on the locality. But we are currently dealing or calculating with the prices on the market.
Quick follow-up one. Is there any opportunity in circularity in terms of applying this process also for recycling? I mean, given the magnitude of graphite and electric batteries, for instance, will grow massively over the next years?
Do you mean recycling of the batteries and the graphite, or
like retaining the graphite in the battery?
Yeah, I mean, I know that there are a few startups also around that try to recycle the graphite that is already around, but we are facing that big supply gap. So even if they are completely successful, that does not close this gap at all. So that's much playing into for our benefit. But our process so far, we have not looked into the recycling for our process so far. So we just really try to implement this process in order to form the graphite, and after that, we put it out as a raw material, and that's it for us at the moment.
Time for 1 or 2 more questions.
When do you think you could be able to produce this at scale?
We're currently working to test our process as best as we can with limited resources, but I would say by 2030, if everything goes well, and we managed to get the funding for a first larger pilot plant, we could start realistically looking at producing at scale with a more realistic data point.
How much money do you expect that you need to reach that point?
Well, that's another very good question. Right now, let's say for a prototype plant with all the best, all the bells and whistles, as you would say, we're looking at 1.5 to 2 million, maybe. This includes all of us being able to focus on this completely full time, which is our ultimate goal. So yeah, let's say 1.5 to 2 million.
Okay, thank you very much.
Okay. Great. Well, let's move on to our last, but definitely not least, startup, Triva.
Right, thank you everyone. Hello, I'm Anjali, founder and CEO of Triva, and we're generating renewable energy from passing transport. Now to explain why, let's start with the backflash. Imagine it's 5 a.m. on a hot and humid morning in Kerala, and you suddenly wake up. It's flash floods, with snakes and rats lurking in the water, people screaming for their lives, and while the water level rises inside the house, you're trapped inside. This happened to my family. To prevent future disasters like this, I'm determined to help reduce emissions and mitigate climate change so that we can reduce the risk of anything like this happening to people. And so we decided to focus on the sector that has the highest emissions of any industry, the transport sector. We're at 37% of emissions and the highest reliance on fossil fuels. This sector is where we can make a huge impact. And the UK railways, for example, used 4.1 billion kilowatt hours of power last year. And with the highest energy bills in the UK, they also have several energy supply risks. They're trying to transition to renewables, but there's several challenges that still remain, including using too much land and being inaccessible, having unpredictable power and slow payback, as well as inefficient and disrupted operation. This is from over 210 customer conversations that we've had. And this is where we come in. Triva makes use of readily available land and passing trains to generate renewable energy, which is predictable, reliable, and efficient. As air flows over the blade due to the turbulent airflow of the passing transport. The unique technology has twice the energy efficiencies of alternatives and can power infrastructure, such as, for example, remote train station lighting, train washes in maintenance depots, as well as EV charging stations. But what makes us different? If a turbine that's a vertical axis wind turbine is placed on the side of a road or railway, it is likely to fail within 3 years. And that is due to the cyclic fatigue that's caused by this turbulent airflow. And when we try to create a robust turbine, there's reductions in power outputs. We've been able to develop the best of both worlds, where standard solutions range from between 12 to 17%, we reach 34% energy efficiencies. As well as this, we save 3 times the carbon emissions by reducing resource extraction, by using upcycled materials, as well as making sure that we can reduce the impact, the negative impact of our manufacturing as much as possible. This means we can impact various different markets, such as passing transport on roads, trains on railways, jet engines at airports, and even the windy seaports on the coast. So we could impact a $660 billion market, but when we focus in on the remote areas of transport in the road and rail industry, there's $12 billion there. And in terms of forecasted SOM, for 2030 is 33 million for us, because there's a huge scaling potential in terms of the shared regulatory landscape and similar infrastructure worldwide, as well as our paid pilots that we've already demonstrated with 11 million of potential revenue on the waiting list right now. So our business model includes an annual subscription of $15,000 per turbine, including the predictive maintenance, and a significant payback of 1 to 2 years. And every year, we could save energy bills worth $9.8 million and emissions equivalent to 220,000 trees if we deployed our turbines across a transport company's network. As a team, we have a wide range of experience, ranging from material science, engineering, and research. So, for example, my background has included working on material science at Imperial and looking at engine cost reduction of 1.5 million for Rolls-Royce's jet engines, as well as aerodynamics and turbulence. Yugu, our co-founder and CTO, is also focused on very much inventing new things, including AR glasses for the colorblind due to his personal experience, as well as first-of-a-kind radar systems, as well as our amazing lead operations, who focuses in on making sure that she uses her experience from UCL PhD and Johnson Matthey research. And we also have a wide range of amazing mentors when the slide comes back. Okay, so we have a wide range of mentors from various areas of industry, including business, commercial and regulatory, as well as strategy. And we've demonstrated integration and implementation within the railways. So working with the paid pilots that we've already demonstrated with Network Rail, the UK's national rail infrastructure company, as well as the permissions that we've already gained, including the Network Rail Assurance Panel, we've demonstrated that we can integrate with the railway infrastructure through these paid pilots. And as traction, we've had over 210 customer conversations with 23 on the waiting list. We've been added to tenders, secured manufacturing partners, and demonstrated the feasibility and technology through paid pilots. And safety is our number one priority. So when we talk about priorities and policy, part of this includes the machine learning and AI that we include within the motor, as well as to include reliable energy and predictive maintenance. And installations in the UK that we've completed demonstrates the integration and the similar road and rail infrastructure worldwide. And as planning permissions are covered by transport operators, we can simplify the process. And in terms of financials, we've generated first revenue through paid pilots, and the $100,000 prize would really assist us with deploying with the 23 customers on our waiting list to hit the potential revenue at the moment. So this is where we started with the university workshop, where we demonstrated our first turbine on the side of a road. And I'd like to invite you to join our journey, as your support could help us with introductions to potential clients as well as experts. And the $100,000 prize would unlock our next manufacturing readiness level for deployments with those 23 customers on the waiting list, so we can help make a positive impact. Thank you so much. We are Triva, making transport systems greener by generating renewable. Happy to take any questions that you might have.
So first of all, thanks a lot. I have a lot of questions, so I have to limit to a few. I have one question. You promised a really great payback time, but knowing that for sure, if you related it to trains are not running 24/7, so the wind is not blowing there 24/7. So, okay, also the sun is not shining 24/7. That's a fair point related to solar. But can you give a bit some details concerning your costs in relation to the payback? And does your calculation include also how you get the energy from your device? Because this is also a challenge, how you get the energy away and what you do with this.
Of course, this is an amazing question. So to start, we provide energy from the passing transport. So even though the passing train could for example, be only every 30 minutes, the turbine continues to spin more than 10 minutes after the train has passed, which is interesting because it means we could have an up to 40% capacity factor, whereas with solar panels, for example, the capacity factor is around 20 to 25%. And when we look at this, there's not only the energy bills that are saved, but also infrastructure, electrical infrastructure costs. So when we try to power a single street light on the side of a road, it can cost upwards of £65,000 just to do the connection of the street light to the grid. Whereas we're providing power directly to that infrastructure in these remote areas, and that's the main focus. In terms of how we do this, the battery technology that we have as a partner, that also is included in this package. So it's a bundle that we have with that the turbine generates energy that is stored in the battery and directly powering the infrastructure rather than including any grid constraints, for example. And as in terms of the second part of your question, what could you repeat that, please?
You answered it partially. The thing was the connection to the grid. So what kind of costs you take into account when you say the customers have a payback in 2 to 3 years?
Yes.
Because you can also just calculate for solar the cost to install it. That's an easy calculation, but you need to bring it to the final destination where it's needed.
Yes, of course. So one thing that's very interesting about this is that we are included within the tenders of customers. So for example, when there is a road being constructed, we're included in that tender. So the infrastructure costs of installation is already covered by the tender, and we are an asset that is provided to the customer. So we provide the training so that they can install this equipment as well. And then that is also translated within this. So that decreases costs significantly. But even without that, because of the costs that we're saving in terms of electrical infrastructure costs, as well as the energy bills, that is where this payback period comes in. So, for example, the cost of the manufacturing asset would be around, it could be around £7,000. And then the installation for 100 turbines can be between £2,000 to £3,000 only. And so there's a significant payback period in terms of how we can provide that energy and the electrical infrastructure cost savings.
So that's just the 14 gigawatt hours per year. Is it for 1 or for 5 turbines? I think I have to do the math. I can solve them all.
So those are for 5 turbines, but I have to also stress that the customer, the reason why we've had so much traction is because we're not only saving on energy bills, it's mainly the electrical infrastructure costs that are in these remote areas. Because, for example, where a diesel generator would be used for maintenance in an area that's remote and they're developing a new road or a new railway track, that area has significant costs for the power and installation, and that is where we provide the payback.
1 or 2 more questions.
Why would you like to make it a subscription model and not just sell it to the customer?
The main reason is because after having all these conversations with the customer, strangely, they're interested in a subscription model. And there's a few reasons for this, but the main is because it seems to be smaller, it's essentially smaller costs for them as a customer, and it continues. So, and also it provides that payback very quickly. And when we look at, for example, other industries like maritime, we've seen that an asset, so for example, selling the turbine for 25K as just an asset and then providing a separate subscription is what they're interested in. But strangely enough, for rail and road operators, they're interested in this subscription. Thank you.
Who's your main competitor? Is it also from similar solutions? Is it solar, or is it even just pushing the awareness that you can do this versus doing nothing?
Yes. So there are competitors who are providing turbines on the side of roads, for example, and also there is competitors with solar panels on the side of railways. So these are two examples. These are included as competitors because they also provide energy in these remote areas. But there is also the aspect of diesel generators, for example, which is used in these areas, and also making sure that we can power those needs as well. So those would be the key competitors. Thank you.
Great. We saw a lot of great pitches today. Unfortunately, only 5 could make it to the final in April. And we have our judges who are going to make that decision within the next 45 to 50 minutes. That's the time we've allotted to it. So please feel free to just go outside, finish off the snacks, make those last connections before we all reconvene here and the judges announce their decision on the 5 finalists. And we present the winner of the semifinals, the check. Thank you all.
Got it. I think like seeing it it's over here tech and how it does. Really. Well,
Just HDMI cable gives out. And this. Okay. Hello, everyone. Thank you so much for your patience. First of all, I want to have another round of applause for all the startups who made it to this point. You all worked really hard, and it definitely showed in the pitches, and that's why the judges had a really hard time picking who the 5 finalists are who are going to make it to the Boston final, as well as the winner of the semifinal. So we'll announce first who make it to those semifinals, and then we'll announce the semifinal winner. But first, let's have a round of applause for those that made it to the grand final, the ones highlighted in green. Great. And now to announce the winner of the semifinal, I'd like to invite one of our sponsors down to the stage to present the check from Alexis from AP Ventures. And the winner for the semifinal is Liftoff Technologies. Liftoff, if you don't mind. Take a picture here with the. Sure. Round of applause again. Congratulations to everyone. Thank you again on behalf of the Climate and Energy Prize for being here. This is such a fantastic day. I'd like to thank our hosts and finally just give Lars here a few minutes to closing remarks.
I keep it really, really short. So first of all, I want to thank you to everyone. I don't want to mention everyone. I want to thank you, everyone. Participants, guests, supporters, MIT colleagues, TUM colleagues, breakthrough colleagues, sponsor colleagues, whatever. So thanks for everyone to make this happen. For us, it was really great. I talked to Todd a while ago. Do we do it once or do we want to repeat it? I can say from our side, we're happy to repeat it. It's a bit now on the MIT side. So I think it was a fantastic thing. I also like the place, honestly. It's nice what they built up here. So thanks a lot for this. For me, summing up, for me, it was really, really interesting to all of you. And I hope every one of you took a learning out of it. And take something with them. I was really, really inspired by all the pitches for that it's students or early stage. I really, really liked them. They were really on a high level in comparison, and we see a lot of pitches. Second, I hope that we gave you also some insights with the two panels. A bit the view with the first panel discussion, and thanks for Anna for moderating this, and also challenge you a bit with the moonshot thing, like in fusion, what can be done. I'm happy on this one. And first, in all, many thanks to the MIT colleagues. For us, it was really a smooth run. And I don't know how many long nights Anna had, but for me, it was a perfect setting. So thanks. And yeah, that's all. Thank you.